In a world of pure imagination. Let's begin with the spin. Traveling recreation. We wish to be. Okay, where are we? Machinarium. Let's see if we can pick up where we last left off and actually get something done today. Let's see if we can beat this game today. That's what I'm hoping for. And then do some more Messy Mansion stuff. Okay. Do we not have audio? Oh, wait. I forgets. I'm having this come through a different... Yeah. Here we go. Now I can hear the game. Okay. So last time we got to the big head dude who is just chilling and spazzing. Not chilling, he's spazzing out here. He is not having a good time. And we were fighting with this kind of difficult puzzle, but it's like the last puzzle. And I think once we get past it, we should be done with the game, I believe. Or at least everything else after this is smooth sailing, as far as my recollection goes. Let me change the audio a little bit though, because it's kind of it kind of rubs on me, you know. It's the sound. It just bothers me. And let's see if we can't get through this puzzle today. Yeah, I forgot. There's like something to this. I just don't know what that something is. I feel so tantalizingly close though. That's the one thing I do know. Meow, meow, meow. In fact, I probably should have taken a picture. I think I did take a snapshot of the solution I found. It's just that I seem to have misplaced. No, it's on my, not misplaced, it's on my Steam Deck. That's what it was. That them joint was on my Steam Deck. Boop, boop, boop. Come on, buddy. Come on, Bobby. I believe. I think we do this if we want to swap them out again. I'm trying to remember why we'd want to do that. Trying to remember why you'd want to do that. Interesting. Something interesting is happening here, though. So I think we're getting close. I think we're super close. It's a matter of figuring out how to squeeze this guy in. We can pack this pretty tightly. Like we could just do this, this, and then this would fit in here. Like this would be the configuration to swap out either the blue chain or the purple chain. And we can do various things with this. I think in our case though, it might be ideal for us to move this up here, because then we can move the yellow up there and then do something with this information. I'm not sure what, but something, that's for sure. Move this in here. Maybe move this guy in there. Yeah, this is this is where we were at last time. This is the stopping point where I got a little bit stuck. A little bit stuck. Because we were like super... It's just almost there, just off by 1. If I can just swap out the position for these guys, where this guy would be like, I don't know, up here instead. That would be really great. Maybe we can do this, but then we're limited by how much we can move and increment. So that's not good. Oh, but we can do this. It gives us an extra bit. That's something. That's something. Na, na, na. Yeah, that's nuts. There's something. I feel so close. I can feel it on the tip of my tongue. I do think the solution is going to involve like swapping these guys out. Like so. And maybe move this guy. Ooh, okay. Idea time. Oh, I think I know what to do. We have to move this guy I think we have to get the yellow into this little corner here. I think that's what. I think that's what's what. Let's execute on that idea of getting yellow there. Which should be pretty simple. Move this guy. The question then becomes, where do we put green? Ah, colors. Yes, Safari. We're having fun with colors today. We're at the end of the rope, end of the game. And the hardest puzzle always comes down to colors and shapes. Where do we put the square? All right, in the square hole. What about the circle? That's right, in the square hole. I wish it was this simple. It's crazy because I solved this a couple days ago on a personal playthrough, and yet here I am struggling against the machine, wrestling. Okay, maybe let's do something real quick. Let's do the thing we did before, which is bring this guy back into the fold. Meow 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 meow. It seems like magic every time I do it. What's good, Safari? Hope you're enjoying yourself. Enjoying from your stressful, maybe not stressful, but your high school life at least. Let's see. Yeah, this should be the last game of Mechanarium, and then I need to find something else to play. That's gonna be a fun, interesting thing to... Okay, what are we doing here? What are we trying to do here? We're trying to get this chain to go the other way. The other way. I'm enjoying myself within reason and the realms of possibilities. I'm chilling, man. How am I doing? I'm doing good. I'm chilling. Just playing one of the games that is very, maybe not influential in terms of what I create, but something that's formed my perception of the landscapes of video games and indie games. It's kind of crazy coming back to it after a number of years. You start seeing like, maybe some things I saw were kind of rose tinted, weren't they? Maybe things weren't as beautiful as I once imagined it. So it's very interesting in that way. Doop. Yeah. Okay. See, the thing is we have to get in this green into the chain so we can start moving them all as a one chain. I feel like I solved this one by accident. I feel like I solved both these puzzles by accident. I don't know, playing The Witness and then playing Machinarium is kind of odd, because The Witness kind of spoiled me in a certain way. And then I go to play Machinarium and it's like, oh, this is this is great by the standards of the time, by adventure game standards. But yeah, I don't know. Feels different. The puzzle designs, the kind of presumptions it makes. I don't know. It's just different. It's way different. And kind of inconsistent. Because with The Witness, it's like you're building, though the rules of The Witness are very consistent. It's just a matter of figuring out what those rules are based off context and whatever. But once you get clued into that, then it's very consistent, and you're purely applying logic onto this growing system, this growing composite of different systems. Whereas here, it's not that. It's just a kind of a hodgepodge of things. Some puzzles seem logical. Other puzzles seem kind of just random. Or requires a jump of logic, or just requires some kind of just clicking everything. Which I guess is the norm for adventure games, but it's a very different thing when it comes to puzzle games, I suppose. And then you get hit with this. I'm not dogging it though. I'm actually kind of interested in, because I never really do puzzle games. I never found interest in implementing them, but now I'm kind of thinking about it a little bit. Like, how would I go about implementing this kind of puzzle system? Doesn't seem crazy at all. But I never thought to try implementing anything quite like this before. Nothing quite like this before. I did something kind of similar to this with a prototype game called Dot Dungeon, like a couple years back. But it's a very different thing. You know, it's meant to be less so puzzle, much more like I guess it's kind of puzzle, but it's nothing like this. Like, this is a catered puzzle, like a handcrafted specific puzzle, whereas Dot Dungeon was like a connect the dots type of game, where all the puzzles are kind of algorithmically generated. So more like your Candy Crush kind of thing, almost. Almost like that. Can I do this? Yeah, it's another way to get this up here, which is kind of cool. I can bring this around town. But yeah, it's very interesting looking at this game with a different, I guess, more matured, or at least more seasoned lens. You know, having played other games in the similar genre. I still love the game. It's very charming to me. And I love the environment and the kind of mood it puts you in. But yeah, very different expectations. I forgot, what is this? There's like a thing I had to do there. Or I think I had to do this. There, oh, there we go. I think I got it. Ladies and gentlemen, we got one on the board. We got one on the board. Yes, sir. We got one on the board. Let's us save. Because I'd rather not lose my progress. Save. Yes, sir. And then we have one last puzzle left. And we're free. Dabi is free. Yeah, I remember this one being kind of goofy. I forgot why it was goofy to me. Because we need one space. I once thought about making a 2-player MOBA where you have to solve really hard puzzles to destroy the towers. The problem is that the learning curve is going to get annihilated as players learn about the game and develop tools that solve puzzles automatically, making games shorter and shorter by the minute and nullifying the gap between pro players and newbies. Yeah, that's true. And also the biggest thing that come to mind as a problem is the volume of puzzles you'd have to make, right? Because a puzzle, the value of a puzzle, maybe not the value, but the difficulty a puzzle poses to you kind of diminishes after you solved it, once you know it, right? At least in most cases. Even this puzzle, it's took a little while, but it's nowhere near as difficult as it was for me the first time I beat these puzzles. So if you're gonna have this challenge of a puzzle for this tower damage, then the volume of puzzles you have to either craft is gonna be large, or you have to find some kind of puzzle game, because you're essentially defining a game that lends itself to algorithmic generation, which is kind of a toughie. It's kind of a toughie, not in terms of the technical aspect, but in the terms of trying to generate something that's a bit novel. And doesn't feel samey or very... It's you either have the problem of like either it's too easy. Like there's that whole game design graph of like, I forgot what it was. It was a graph of difficulty versus boredom. And there's like a Goldilocks range of difficulty where it's not trivial and your brain is not off, but also not overt too difficult and discourages play. Yeah, it's one of those fine line situations. And this locks itself in. And we've tried this configuration already. Technically, I've designed custom low-effort encryption obfuscation algorithms that I could just have applied to string, which would be shown to the player and then be decoded Then how to notify the player of which algorithm it is to not break flow whilst also not being too obvious for the new players.
I would need to see what you're talking about to understand what you mean. Like, I'm assuming you're just talking about
Giving the player a string of encrypted text, and then they have to, as you said, right, figure out, like, are they gonna be aware of the different set of algorithms you have for encryption and then, or encoding, and then they have to try to suss it out. I wonder what that would look like. Has the problem of only being fun either at really ridiculously high levels of simplicity and competitively, or if it was completely unintelligible and took years to figure out, but nowhere in between. Yeah. Well, if it's the year time scale, then the rest of the game is kind of, the whole tower defense thing is going to be very. Well, I guess you could technically do that. It'll be in the same kind of, because there's games that exist like that, like chess, where maybe not years in the time scale of years, but there's chess games that have taken months to complete, where they just take so much time in between each move to process and before taking an action. So you can be like, invite that to be part of the gameplay, where it's, hey, this is a MOBA, but it's super not high frequency, and you guys are gonna be committed to this game for a fat minute. Which, as far as a unique experience, 100% provides a unique experience. As far as how much of a sell that is, that's a different question entirely. But hey, why limit yourself to making games that are products? Why not just make the thing for fun? I'm sure there'll probably be someone out there who's gonna find the idea novel enough to give it a try. I forgot what we do here. Oh man. Going in circles here, man. Literal circles. And the green hasn't even left this quadrant. I think that's the biggest thing here. Yeah, I don't know. I've been thinking a bit more about games. There's this great talk from Brian Moriarty. It's called In Defense of... what was his face? Not Grant Kirkhope. Well, who's the guy I'm thinking of? He's a film critic. Let me go on YouTube. Sieber, I think. Brian Moriarty. In Defense of... I spelled his name wrong. Defense. No, apology. An apology. That's what I was thinking of. Yeah, Roger Ebert. Roger Ebert. And the whole premise is that Roger Ebert is one of the guys who said video games cannot be art. And everyone just railed against him and said, nah, you're dumb, you're stupid, video games are art. But then he breaks this idea down in defense of his original claim. And Brian Moriarty is a great game designer, at least to my understanding. And he took me from someone who was like, how you're going to defend this claim that video games aren't art? he took me from a place of immediate hostility towards him and then by the end of the hour talk, I was like, you know what? I see what you're saying. I see what you're putting down. And it's kind of redefined what I consider art in the first place. Now, do I fully agree with his take? I'm still trying it out. I'm still trying to see through this lens and see, does it make sense? Is there a net benefit to approaching these thoughts in that way? What makes it seem very appealing? Because he describes the differentiation between kitsch art versus like I think he defines it as sublime art or and there's also another distinction between that versus the art like tied to a craft, where there's like there is this like the act of producing or modifying or transforming something can be viewed as the art of that craft, right? The art of game making, the art of motorcycle repair. That's one of his examples. The art of war. So that's another type of art that is used, but that's not the one he's trying to describe. But he specifies it to differentiate between what he's actually talking about and what Roger Ebert's talking about when he said video games can't be art, or at least that initial claim he made, versus the other connotations and usage. And the reason I find his take to be kind of alluring or interesting is because it's kind of puts to words something that I've been noticing and something that I've been kind of observing, but I didn't know how exactly to describe it. Where there's like a class, I've started to see like there's a class of games in my life that I play, or at least recently, where like there's a distinction between them, between games that are just kind of pop, like they're just filler, I think, to me, that may not demand, but just consume time. And honestly, I'm not sure to what kind of value I got from it, and versus games that seem to be a bit more substantive. Put an example of old ones I made up called Pinth in the Discord. Let me check the Discord. But yeah, really interesting talk. To show your stuff. Oh, so this is something they would receive? Yeah, it'd be super niche. Super niche. Jeez. Passphrase for this file is I like. Okay. Interesting. Okay. Very cool. That sounds like a gnarly game. Alright, we're gonna walk outside. We're gonna get a breather because this is kind of a very tense room. It's kind of a tense room in there, man. Tense atmosphere. Okay. Step out for a little bit. I don't know why this doesn't seem to work very consistently. Like sometimes it works and sometimes it doesn't. I don't understand it, and I don't do anything different. Yeah, like it's the same exact thing. Does it actually require the bottom note? I never heard that in the radio. Maybe it was just too low for me to reach. It does start with that note. Oh my goodness. I guess I was just wrong. I was just wrong. All right. Good to know. But yeah, it's been a very, very interesting thing. At the very least, though, there's plenty of games that I would defend as art. But now, after watching that or listening to that talk, the defenses I would make about it would be very different versus the common defense of like, hey, it makes you feel things. That's why it's art. It's very different. A very different justification, very different reasoning. Way, way different. Can we just... I wish we could just work with this like that. I wish it would be just that simple. Like within this configuration, get this guy going the other way. But like everything in this game is just by off. It's like off by one, or at least with these puzzles, there's a bunch of scenarios where it's just off by one. One marble, one little ball, makes it far more difficult. It is the worst. The worst. Like, I need the green to go down there. That's what I really need right now, man. They won't let me have it. The green keeps getting stuck in this corner here. And I'm doing all within my power to try to get him out. But yeah, as the kids say, I've been very Moriarty pilled as of late. And by as of late, I mean like the past couple months. I think it kind of started with listening to The Secret of Psalm 46. Which was also another Jimmy Neutron brain blast for me. Oh, please, let me just get the thing out of there, man. You're killing me, man. Okay, if this doesn't work, let's do something different. As Einstein said, doing the same thing over and over again, or the same thing over and over again and expecting different results is insanity. At least that's what I've heard spouted all my life. I'm not going to question it now. Who am I to question sage wisdom? From the math, the man, the myth, the legend. Anything comes from this configuration. Anything of value from this configuration. Nothing that I can see. Nothing that I can see. Like, geez, man, that green is just stuck in there. No matter what we do. Oh, 1 second. Come on, dog. If we can't do it soon, within the next, I don't know, let's say 30 minutes, maybe 20 minutes, we might just switch off and then do some art, do some actual game deving. Playing games is cool. You know what's even cooler? Actually getting a game done. That would be really cool. That would be the cat's pajamas. The cat's meows, the bee's knees. That would just be swell if we could do that. It's always a 1. Let the green out. Let the man be free. Let the boys out. They want to hang. Okay. We can start this process, but it's not going to... It seems like it's not going to go anywhere. Like, ideally, we'd have this be able to move one more so we can get this link over, but that seems to be out of the cards. Out of the cards. Without putting the green back wherever it is, and I don't want to do that. I really don't. That's not a desire I have. So instead of doing that, instead of doing this, what is a gamer boy to do? What is a gamer boy to do? What is a gamer to do? What is a gamer to do? I just want to play games. That's option 1. Let's do that. Option 2, we know it doesn't work here because I'm gonna get blocked up. This option, this path, puts us in this predicament. We can go put the green, yellow through here, but then we're gonna be in that whole rigmarole of just cycling over and over and over and over again, which is madness. We can bring this all the way over here, but that's gonna be stuck, as we've seen previously. We can try making this guy go down, but then again they are stuck. They're stuck. No movement can be done. They're gridlocked. And these yellow blocks all movement. This makes me feel like I'm going crazy. And yes, we've gone through here again. We've gone through this before. Where this is gonna get filled up. And there's no room for this stuff to move. I can try doing this 1. So there's space here, so this can go down this way, down this path, and then this can go here. And that frees up some space there. But again, I will reiterate, we're back at this configuration, which is locked. Gridlocked. Improbable to move. Now I can't do any further actions down this way. At most, I can bring this up, and that happens, but that really does not produce anything good. At most, we can just wiggle and jostle this guy back and forth. So this is a no-go. Unless there's some magical way I can bring this here, but then this yellow gets stuck. Unless... Oh my goodness. Okay, this is not great. We're back to a bad place. A not great place, but this is something. This feels like something. I want to believe that this is something. Let me believe That there was meaning in this. In this toil. That this was not for naught. But that the grind was meaningful. Please, game. Give me the sensation. Oh, brother. Yeah, and this configuration sucks. Makes you think there's hope, but there's no hope there. It's a stinker. It's a breathing room, but it's limited breathing room. Again, another example here. Set property. And we could do this whole thing again. Okay. This may be... We got one on the board today. One on the board today. We can just take that check, cash it in. Say we're happy about it. Even if we're hurting inside. Yeah. It may be that time. The ET phone home. Cool. We'll just do that. Save. Save. Yes. Quit. Quit game. And we'll just do some pixel art. I want to do some more boss cycle stuff with this game. In fact, let's even change our stream name. Me make game. Yeah. I'll put on some not Moomin. I like it, but it gets me copyright struck, so we'll instead listen to SCP ambient music sounds for a little bit. You know, something very nostalgic, makes you feel like I'm back home in the SCP Foundation. Good talk. Good talk. Listen to. Yeah. Oh yeah, I was gonna go to Twitch. That's exactly what I was coming here for. Yeah, edit this guy. Make it software. So we can make some game stuff. Some revisions to the level, some revisions to the shadow casting system. We've done quite a bit. I kind of want to work on Anton's animations a little bit. Maybe spice him up, make him a little bit more difficult. Potentially make the blobs dirty the level once they hit solid ground. That would be pretty cool. Pretty cool, if I do say so myself. I would very much enjoy that. Also, maybe modify these sprites a little bit. Aren't these shadows lovely? I'm happy with our custom light system. She takes some work, but she's worth it. Let's go to shaders. I want to turn off the stuff. Let me turn off the miasma stuff, the goop. Turn off the goop. Yay! So we can see the bare level, clean version of the level. And I kind of want to implement a new system here, guys. My dudes, my guys, I want to implement something a little different. It makes me feel hesitant though. But I think it may actually be worth it. I just have to think about this. So we have this dirt system. I'm looking at my whiteboard right now. Let me do a few things first and then we can come back to this. I kind of want to retouch some of this stuff here. Also, let me visit the lobby because I did some fixes, I think, and I want to see how things work here. If the lighting's gotten worse or better. Hello, Lloyd, compute. It's using per pixel lighting. Very interesting. I think there might be invisible elements in this game affecting this. In all actuality, I do believe this might be the thing. Which means, and this highlights a thing that we need to address. Which is, we need to have our light ray casting ignore volumes that should be ignored for shadow casting. That may be existing only to just cast. That may exist purely just to do specific, like prevent players from walking to certain areas or whatnot. We need to have a way of differentiating it. So let's make another. I think the easiest way might be making a layer called shadow ignore shadow cast. Excuse me. Ignore shadow cast. And that is now a layer that now exists in game. And we can go to the cube, we can set this layer to ignore shadow cast. And then now we should be able to go to our little script here, our little cast, cozy light settings, actually cozy sun. And we have to modify our little script here, our raycast, to make sure it ignores that specific layer. So is there a thing for, or is there overload that has into layer mask? Yes, the integer for the layer mask. Perfect. I don't know if you have to do a bitwise inversion. I think it's just marking it. I think I know for a fact our layer is 6. Yeah, 6. So you just have to mark that specific bit. And we should be good to go. Layer mask. And now when we render, we can at least ignore that collider. And life should be good. Life should be all dandy. Let's go to Sun. Compute. Okay. Marginally better. Not great. Why is this the case? Seems, oh. That might be part of it? Something very weird with this light setting. I feel like there's something else blocking everything here. If I'm not mistaken. But it strongly feels like there's something else afoot. Is trigger, yeah. Also, application should be at the very top. I don't know what you're doing. Yeah, these barrels and tables and whatnot, that's not important. You have a quad here. That should also not be important. Interesting. Well, that's a trigger collider, though. Do we? Does our does this know to ignore triggers? It should. In fact, I want to make sure it does. Ignore. Yeah, that seems about right. Hopefully, that's just the big thing here, that we just had to ignore triggers and it would be fine. Though this is also a point of concern. This shouldn't be way more, should have way more value range than what it currently has. So that's strange, weird, incorrect even, I would say. And all around just dog water. Ray depth of 20 meters. It's like big enough, more than enough. Intensity, that doesn't matter. 512. Yeah, we're having the same values. This is so much more worse than we had last time. That is incredibly weird. light vector is correct. I should probably make a better indicator that shows the direction of light for this guy, though. Make my life easier, that's for sure. So let's just do that. Draw sphere. Transform dot position. Depth world. No. No, you're not. That's gonna be way too. Radius of 1. Another one at plus direction. That should be fine. Your direction is what? Vector 3? Vector 4. Of course, to vector 3. So I have to do some casting. That's fine. And radius of 0.5, let's say. That sounds good to me. And then lastly, I would greatly enjoy having is that it? I think that's it. I think that's pretty much everything, actually, if I'm not mistaken. Yeah, I think that's about everything. Whoa. Maybe not. Maybe it's not great. Maybe the sphere does not look very great. Let's do 0.5. A radius of 0.5. And this of 0.25. They should not be touching. Hi, are you coding? Yes, I am. A little bit, unfortunately. Not unfortunately, I do enjoy coding. We're just trying to solve some issues here. How do you know? How do I know if I'm coding? That's a that's a metaphysical kind of question, isn't it? What does it mean to code? Are you really coding if you're not using a magnet to move pixels and bits around? Yeah, some coding here and there. Can you teach me? I mean, what would you want to know? Coding is kind of a lifestyle, man. Monads? Oh my. Dude, monads are so easy, man. They're just Indo-functors in the category of like... I joke. Yeah, there was what's that meme, that post? They're just monoids in the category of Indo-functors. I mean, monads aren't crazy though, to be honest. It just feels like so much of the... It just feels like so much of the explanations around them is just terrible. But I really don't use monads at all. No, I do F sharp for work, so it's just ivory towery. F sharp. Yeah, I'm your less probably. Hey Vsauce, Michael here. I'm currently coding, or am I? Are you really coding? And this is a monad. Yeah. Yep. And then like all the system link stuff too, or a lot of system link stuff is with it. Yeah, you just don't consciously think of it like that though. I have a coworker who's super into functional. He's like super looking into. He always brings up. He's like, hey. He's like the two questions. He's like, hey, are you learning assembly yet? And hey, are you doing Haskell yet? But he's cool. He's cool. He's cool though because I feel like he comes in with a hot take, and I don't like it. But then, like, I start looking into it, and then I'm like, oh, you know, actually, I see the merits. I actually enjoy this. The best case, I enjoy it and I use it. So in the case of like reactive extensions, that's what happened to me. I was like, initially I hated it, and then I started seeing the utility of it. I started trying to do everything with it, and now I'm kind of going back around to being like, maybe we shouldn't use it for everything. But I'm leaning away from static typing. I like functional, but I'm leaning away from static typing. Interesting. That's kind of crazy to hear. That's kind of crazy. That's some crazy talk a little bit. I'm not gonna lie. I usually hear people going like from non-typed to typed and then having this whole, like, that's what happened with me. But I've never seen the opposite of like, hey, static typing, nah, let's come back. Let's go back. Typing proponent. When you go too deep into static typing, you kind of bounce off of it. Yeah, static typing, like, well, I'm kind of curious about this actually, because I'm not sure what you mean by kind of bounce off of it. Because, or I guess I'm interested in knowing what you mean specifically by that. Because there's some bad stuff that can happen that is kind of not directly caused by static typing, but is allowed based off what it enables. Give me a second to explain. Okay, I'm not gonna rush. You have the time. You have the floor, tofu, the lofu. Discord you if you want and chat on Discord, like a call. I have the Discord. Do I have the? I want to hear this. This is gonna turn into. This will be a brief thing. All right, because I'm interested in hearing this. I'll join the voice channel real quick. It's me kind of quick though.
You can hear me.
All right, I can hear you. Let me bump up your volume a little bit. All right, try talking again.
To hijack your stream.
No, you're good. No, this is an interesting take though. This is an interesting take.
No, it is a hot take. It really is, and I get it. You know, I really do get it, because it's just like, I mean, I think as we age as developers and stuff, we kind of learn things that and change our like preconceptions about programming, and it's like, oh, this is the best, or this is the best, right? And I'm not saying, oh, static typing is bad. First, I don't want to say that. I want to give you a little bit of kind of like history, okay? So I was doing like C# at my work, I don't know, years ago.
I feel that.
Right.
Mm-hmm.
And I was like, oh, C#'s cool, I like it, right? And it's like, C#'s the best. And if you were to ask me, well, what else have you done, like professionally? I've been like, JavaScript maybe. And it's easy to compare against JavaScript, I guess, right?
Mm-hmm.
I didn't like really try anything else, right? I didn't try anything else serious. But I was like, man, there's something wrong with like how I'm organizing this project, and not that C# is bad, but it's just I was organizing the project that I was working on like in a messy way.
So
right?
question. So when you say you're not organizing the project well, what does that look like? They have to put you on
like
yeah.
No. You're right. So I felt like it was difficult to extend. Anytime I needed to add a new feature or whatever, I would be deleting and rewriting code.
Okay.
And you have to understand that like when we go through college, right, we're like taught like the dogma of programming. Mm-hmm. I don't mean that. I mean it's like solid principles, like open closed principle, right?
Yep. Dry, solid.
Exactly, right. And so when you're like going through this stuff, you're like, huh, this feels like it's breaking some of the principles that I learned, right? And so I'd actually talk to people and I'd be like, hey, I feel like my project, I'm just organizing it wrong. Like I feel like it's really weird that like I'm coding this, like, and it seems fine, but eventually it kind of gets messy. Like I have all these objects, and how do I know what belongs in one object versus what belongs in another object? Right, mm-hmm. I was just very junior.
Yep.
And the answer I got was that's just code. That's just life.
Yep.
Right? All code is messy, right? And I didn't like that answer. I'm kind of stubborn, I guess.
Mm-hmm.
I'm like, well, I felt like there had to be something more, right?
Dude, everything you're saying right now is like what happens before someone says, and that's why I started this language, or that's why I wrote my own.
You're right.
Yeah,
You're right. And so, I was looking, and I eventually came across like functional programming in F#, right? I was like, whoa, this is really interesting. Because to me, I felt like functional programming, it was offering me like, because when I would take solid to its logical end, I ended up with something that was ridiculous, but it was like one interface with like one function in the interface, or one method, I guess, in the interface.
Yep.
And the implementation can implement that, and I'm like, that's a lot of boilerplate. When in reality, that's just a function and a function signature, right? And so when I took object-oriented solid to its logical end, and by the way, I'm not hating on object-oriented. I like object-oriented. I still use it. I
have hot takes about that as well. And in fact, a lot of things you're saying, I've actually either talked about previously in previous streams, and I've been thinking about it a lot because I've gone through the same dogma of you're taught object-oriented programming and this dogma about solid principles, and then you go to the work and you start doing that, and you start trying to apply it everywhere, and then you start. I'll let you finish your point first, and we could talk more. We can wax on about this more.
No, I mean, I think you're right, but like, I remember one time I was watching a Nick Chapsis video. I don't know if you've heard of him before. He's like a C# guy. He's kind of hip, I guess, with the kids.
Okay.
And he was going on about like why datetime, like why you shouldn't use datetime.now in your code, right?
Okay.
And what you should do is you should have a datetime interface that you bring into your code because it's testable, right?
Okay.
And I think it was kind of at that moment I'm like, this is ridiculous. Like, I just want to like get the datetime now, and I guess I could inject, like literally go through constructor dependency injection to bring in a datetime interface, so I don't have to like literally bring in a datetime, so I can mock the datetime with an injected value. This is ridiculous.
Yeah.
Is kind of what I was thinking to myself.
Yep.
When F#, they would just say, well, just pass it in as a parameter. Just isolate your side effects to sandwich whatever, the input output. I don't know if you know a ton about functional programming and their dogma, because they've got dogma too, right?
Yeah.
And I disagree with some of it too, and I'll kind of get there. I know it's like kind of a long-winded thing. I didn't actually think I was going to start this far back, so I apologize.
Hey man, I'm interested. I want to hear where this goes.
And so I was like, okay, this is cool, but like no one actually does functional programming, right? Like this is just kind of idea, right? And I saw there's a company, and I still work for this company. They actually had a job listing out. I was like, screw it, you know what? I don't know. I don't know anything about F#, but I've read a book on it at that point. And they interviewed me. I was like, yeah, I don't know anything about F#. And they're like, cool, you're hired. I was like, okay, we'll teach you. So I was like, wow, yeah, that's cool. And so I've been doing that for like 3 years now. Oh yeah, the SC.
Yeah, dude, that's so funny. That's so funny.
Propaganda. This is propaganda. That's the secret. All programming is propaganda, right?
Oh, it's like it's fashion. Like there's things that come into fashion, and things that come out, right? Right. Both from the ideological, even to the tool level. Like even like Rust went through a phase of like being touted everywhere, and then now it's kind of faded out, and other things are coming in. Dude, that's Rust is what I've been. I committed myself to working with Rust for like the past 2 or 3 years, and I've gone through like this whole cycle just to end up at a place where I'm like, you know what? I'd rather just use C. I almost feel I'd almost rather just do C or C++, but without inheritance, any of that stuff. The only C++ feature I'm using is purely just function operator overloading.
Right. Yeah. So I actually think we're kind of in a similar kind of journey here, because I think Rust is very similar to F#. And so some of these things I think you'll be able to relate to this. So I'm doing F#. F#'s great. You got your Hindley-Milner types, right, or whatever. You've got like the discriminated unions or enums in Rust, right? You've got your results, your option types. This is cool.
Optionals.
Bug-free code. You're thinking this is great. And then you start working on the domain. You're like, wow, I can model my domain. This is super cool. I can create constructors or whatever, and for my domain, so it's like really nice and can support all the different variants or whatever.
Okay.
Until you get into the client's like, okay, this is cool, but can you document this? And you're like, yeah, I guess I can do that. And you start looking into documentation tools, and you're like, oh, wait a second. A lot of the tools out there don't support F#.
Yikes.
So it's like, okay, we're gonna have to write this by hand.
So a question: when they say documentation, right? It's documentation for people who don't have access to the source code. I'm imagining, right?
Yeah, I mean, if you got an API or whatever, you just want to document it, like open API spec, whatever. Like, not a big deal. This is pretty like normal, right? It's like, hey, can you give us an open API spec? And it's not like I'm pitching to you as it was this narrative as if we didn't know about it. It's like, of course we knew we needed an API spec, but I'm just kind of like saying, okay, well, now we're to the point in this project, we need to document this with an open API spec. And they don't play very well. And what you quickly realize is types don't encompass enough. And this is interesting. You're like, well, why not, right? Well, it's because if you have an odd, let's just do this simple example of an odd type.
Okay.
Right, like you're creating a new type, and it only contains odd numbers. The only way you can enforce this is at runtime.
Yes.
You can't enforce this unless you have something called dependent types, right? Which I think there's some Rust macro that can probably do that. In F# you can't do it, really. And some other languages, like, I don't know, I'm sure some version of Haskell can do it.
Yeah. Languages that have like pre-compilation or compile time stuff that you can execute to enforce that kind of stuff.
Right.
Like I know like Jais and Zig has a bunch of stuff that's related to that would be applicable in this case.
Right, but overall, it's like a really difficult thing to enforce these, like, and that's just with like an odd number, right? That shouldn't be too bad, right? Like that's just an odd number. What about like when you want like a type that is like, oh, this type has to be this value if this other value in the struct is this.
Yep.
Oh, okay. Well, you would actually have to enforce that through your runtime logic.
Yeah.
So if you want to say, hey, I want to document this to someone, well, also now your code, your documentation, your code is mismatched. Like it is literally like desynchronized from each other because
so
the JSON spec can cover that, and your code can cover that too, but they're represented. One is declarative, and the other one is through imperative or functional code.
So when you're saying types is limiting to you, right? It's not because usually the idea is like, oh, types are too constrained, so we are going the opposite direction. But it seems like it's like the opposite direction for you, where types do not provide enough specificity, right, to work with, and does not provide a guarantee. That's like what I'm getting here. So if I'm correct in that assumption, what is the direction you go from here?
Right. Yeah. So no, that's a good point. And so it's like, okay, now that you have that, now that these types don't seem to play very well, kind of in this real world, and I don't mean like that they don't play super well. It's just all of a sudden you're starting to run into all these different things. Like, for example, DTO explosion. This is another problem where it's like, hey, I've got a person type, right? And all this person type is just has a name, has an age, has whatever, right? I don't even know if this is actually like a common thing. So if you're looking at, I don't know.
Yeah,
this
I'm like
DTO
DTL explosion. What is this, dude?
Right, like a DTL, like a data transfer object, like a simple POCO object, POJO object, whatever.
Okay.
Where it's like you're trying to bring something in through an API, right? And so what you want is you want this to be the most simple, bare bone types of things. You're not putting a lot of validation on this.
Okay.
Because it's not in your domain yet. You haven't validated it to your domain yet. And so you have this DTO, and then you want to validate it and parse it into your domain object. And then whenever you want to do any work, you have to like validate it, basically turn it back to a DTO and either put it into a record or a database, and eventually you just have all these DTOs of, like, for example, like a person, like I was saying earlier.
Mm-hmm.
If I have a person and it has like 3 fields on it, but I also want to add a 4th field on it in a different context, I'm creating an entirely new type.
Yeah.
But the thing is, these 2 people, or this person object, logically represents the same person in the real world, right?
Okay.
Like if someone showed up and said, "Hey, I'm Chad," and then a week later says, "Hey, I'm Chad and my favorite color is now blue," you're not gonna be like, "I don't know who this is."
Mm-hmm.
Right? It's like, no. It's like,
the same thing conceptually.
It's representing the same person, and this is because data is we append data together. I'm forgetting the word for it in my propaganda, in my religion.
You're not. You're missing your pamphlets here, man.
I'm forgetting the word, but what I'm trying to describe is data. You append data, and it doesn't really care. Like data doesn't care. Computers shouldn't care if you add more data to this. So, for example, if you have a form, right? You're going to the doctors, and you're writing on the form, and there's something you want to tell the doctor that isn't on the form. Well, you can write it in the margins. And the paper doesn't burn up and explode because it can't compile.
Okay.
Right. That's acceptable because the secretary is going to be like, "Oh yeah, this is just additional data," and she might like throw it in the notes or whatever. She just might give it to the doctor. This is fine. And so if we want to model the real world, sometimes we're very exclusive with our data. We say this is the data, but we accept no more. Right.
Okay, so you kind of want to have malleability while still maintaining the identity of the thing, the object or thing you're describing here, right?
Right. So this is where duck typing kind of gets really interesting. This is where like I started going down the rabbit holes of like pure script, right? I don't know if you've heard of that language.
No, you're taking me to new territory right now. Duck typing and pure script are new to me.
So duck typing you probably kind of heard before, where it's like if it looks like this, if it talks like this, if it has these attributes, we can essentially say it is this type, right?
Okay.
I think this is more popular in things like Golang, kind of. I'm not a huge Golang fan. I think in Python too they do this.
Okay.
Could be wrong. By the way, I'm not like saying, hey, duck typing is the solution either. I actually don't think it is. But this is something that can kind of alleviate this because you can say, hey, I'm working off of something that must have these properties, but it could have more, and I don't care if it has more. Does that make sense?
Okay.
I just need it to fulfill this subset of a contract.
Okay. So kind of like
Right.
nested traits or whatnot. Or just traits in general almost.
Yeah, I think so. Traits are like type classes.
Oh,
but
in
Rust, right?
Yeah, in Rust.
Yeah.
They're kind of like type classes. They're almost like, I almost think about it as like interfaces that can have default implementations, but they can also be chained and filled in different ways too. But it has that same kind of side effect that you're talking about, where you can kind of composite different types of contracts onto it, and then you can kind of, if it has that, you can just view it as that thing.
Mm-hmm. Yeah, it's similar. I think duck typing is a little bit more loosey-goosey, right?
Yeah, because what I'm thinking
you
is
don't-
more like polymorphism at this point, right? So like, where is the distinction between like duck typing and that? Or is duck typing like a specific subset of that?
You're asking some really good questions. I don't think I could give you the exact answer to.
Okay.
I think the actual thing is you can pass something into a function and it might not implement that interface or trait or type class explicitly.
Okay.
Where duck typing will just look at the thing itself and say, yeah, this fulfills a contract.
Oh, okay, I see. So you have you have this definition of what this contract is. It'll observe, like it'll look through the object. If it has the requirements for it, even if the class doesn't inherently or explicitly implement that, if it just has like something that has let's say method signature in this case, right? It'll say, oh, that qualifies, and then runs it or
Right.
works with it. Got you. Okay.
Right. And so again, there's pros and cons to this. Like, this is all trade-offs, by the way. This is all trade-offs.
Yeah.
And so I was looking at this. I was like, oh, this is really cool. And I was looking at I'm like, oh, I really liked what I've learned with functional programming. I'm just like not enjoying the strictness of it. It feels very cumbersome. And then I was exposed to Clojure. I know. I don't know if you've heard of Clojure.
Yeah, I heard of
don't know if
Clojure.
you've
Yeah.
heard of Clojure.
Yeah, Clojure.
It's tough because it's a Lisp, right? And people have a hard time with Lisps, right?
Mm-hmm.
And until you drink the Lisp Kool-Aid, you're going to sound crazy. Like, you can't escape it, right?
Mm-hmm.
And that's the thing. Lisp, I've found, is the most polarizing language because either you've drunk the Lisp Kool-Aid or you haven't.
Yeah.
Right. I don't think I've ever met anyone who's like, yeah, Lisp is pretty cool, but it's just not for me. Like, it's just you either accept it or you don't, right?
I think I downloaded it, like the Lisp runner locally, but I still have yet to actually go through a guide and try learning it. But I
Right,
see like the
and-
byproducts of Lisp, but that's a very different thing than actually using the language itself.
Right. And so since Clojure is, a hotly debated subset of Lisp, which is, again, very hotly debated because some people don't think it is, some people do. I don't really care. It looks like a Lisp, so I think it is a Lisp.
Yeah.
Lisp has a lot of Clojure has a lot of unique kind of properties where they're more focused on specs.
Okay.
So they recognize, hey, they're a language that they recognize, hey, static typing is cool, but we feel like it's limited. And not like it's limiting as in it's constraining them and that's annoying to them. That's not what they think. It's more like it's limited as in it's not fully able to express the different types of variants or the properties that they want their types to have.
Okay.
But they do feel like specs can fully express that type of thing, where they can declaratively say, hey, this string has to be this, or in the case of this, it can be this type of thing too, right? And they can declaratively express that type of stuff. The downside is they give up compile time, like it's dynamically typed, right?
Mm-hmm.
So essentially, Clojure, they're giving you this, they're offering this to you. They're saying you can fly. We're going to give you wings. You can do whatever you want,
Okay.
but you have to take off your helmet. You have to take off your shoulder pads. You have to take off your shin guards. You just have to trust yourself that you can learn to fly with these wings, right?
So,
And so some people-
Clojure is the final solution that you're approaching here, correct? Or is there another
It's not
chapter?
the final.
beyond this? Oh, it's
I mean,
still
there's
okay.
no. So that's the thing. I don't think any Clojurist will be like, Clojure has it figured out. I'd say if we're going off of the themes of religion here, that Clojure is the polemic to modern programming languages,
Okay.
which is kind of like the criticism of modern programming languages, right? And so they're able to accurately say, well, here's the problems of the modern programming languages. And instead of and they're trying to work on solutions,
Mm-hmm.
but they're not able to fully create them. Like, I don't think anyone would say, hey, spec is a perfect solution and a perfect replacement for types. I don't think they would, right? But they're working on it, and the designers, they're going through this, and they're saying, hey, we haven't figured it out. We haven't figured it out. And Clojure moves very slowly because it's it's a Lisp, which is has a tradition of moving very slowly. So, for example, their spec library has been in alpha for over 10 years. I mean, this has been in production stuff for that just as long.
You said
But it's
Clojure
because-
spec library.
Yeah, like Clojure spec. Um,
I'm interested in this. So it feels like we've
with
died
a J.
with a J.
Clojure with
Oh,
a J,
Clojure.
yeah.
My bad. Not
No, you're
Clojure.
good. It's pronounced either way.
There we go. Spec guide. So I feel like it's very interesting, right? Because I feel and I've gone through a lot of the similar things you're describing. But I think in my case, I kind of diverted to a different place. Because it seems like you're trying to find tools and find, not dogmas, but something that will help. It seems like you're trying to pursue modeling objects as what they are, right? And types are failing to do that without permutating a bunch of other types, right? Which are not, you can't just swap them in and out, right?
Mm-hmm.
Whereas this solution you're coming across is a better way of kind of compositing different properties onto one conceptual thing. Is that correct?
Yeah,
Okay, cool.
it's pretty loose. So again, spec is more about validation than it
Okay.
is about conforming to specific types. So
Okay.
just a real quick thing: if you have Rust and you have, and you're making a domain, and I don't know if you've ever done like a lot of heavy domain modeling, like in Rust, where you, or like in functional programming, like where they really say, hey, whenever you should never have a primitive
Okay.
in your domain. I don't know if you've heard that dogma
No,
before.
never.
So they're saying don't have a string, don't have like an int, don't have a number, don't have float. You should wrap that with your own concept of whatever exists in your domain.
Okay.
Right? So like instead of a number or a float or an int for age, you would have an age type that wraps whatever number you choose, like float or whatever.
Okay, I've seen
And
this kind of
then-
thing. Yeah.
Right.
Yeah.
And that sounds really cool because you're like, wow, my domain's so safe, right? But the second you want to start doing operations between like an age and maybe someone else's age, right? You want
Mhm.
to get the difference between the two ages. I don't know. Or you want to get the difference between just another random number, or you want to add like, well, how old would this person be in 20 years?
Mm-hmm.
Well, you either have to go to the age type and start adding additional functionality to say, oh yeah, you can add a number to an age. Or you have to unwrap the float outside of that age type so you can actually perform mathematical operations on it.
Yeah.
And that's cumbersome, right? When you're just like, oh my goodness, I'm just trying to add 20 to this age or whatever, or 5 or 10.
So
And-
this is. Oh no, continue. Finish that thought.
Yeah, I was pretty much finished with it.
Okay, gotcha.
Yeah.
So that's okay. So you're kind of confirming that idea, right? I mentioned that I started doing some Rust stuff a while ago, and I've kind of gone through a different rabbit hole. And I think the way I've started to think about, and it's kind of not saying it's necessarily right or wrong. It's just a different problem space that I'm occupying with this, right? Where I've started going the opposite direction of being, I don't want to think about these things in terms of what they conceptually are and dealing with that. Instead, I want to think about things in terms of data. In this case, like for the context, right? I was working on a game engine within Rust, right? To get a better understanding of this kind of like, how engines work, how I want to implement some rendering ideas I have in mind for my own specific pipeline and all that kind of stuff, right? And I've gone through cycles of trying to approach it the way I was kind of taught, which with solid principles and all that kind of stuff, and then diverging away from it. But what I started realizing is that the more you try to think about, the more you think about the modeling data or having your data model real world things, you start having some sacrifices in other different places, such as like how well packed your data is, right? Or even things like cache coherency and whatnot when you're working and operating through larger sets of data. And I started going through this whole pathway of, okay, instead of thinking of data as a conceptual thing, or having my types try to model that, instead, what do we decompose it into primitives and start working on that, so that we can prioritize less data volume, because like, with data alignment with instructs, you start having this issue where you start having a little bit of bloat there that happens, which in the most times when you're writing application level code, which like I do for my day job, that's not really a big consideration. But if you're doing something that's going to be, you're trying to be ultra performant for whatever reason, that starts becoming a thing that you start thinking about. So all of a sudden, I kind of had to start breaking principles, both from like solid and whatnot, to get better performant code. But also, not only breaking those rules, but also I started having to break Rust. So I've gone through a different pathway where I started writing with Rust, and I try to do things not, I guess, idiomatic to how Rust defines how you're supposed to do things, and then exploring different ways of doing that. But then as soon as I started trying to prioritize those things like space and performance, I started realizing that I'm encountering more and more places where I have to actually break a lot of rules for Rust to do the thing that needs to be done. But at the same time, code complexity kind of went down for me in that case. But it would be very different compared to like an application level logic. And then now I've gotten to that point of, okay, for this kind of specific problem space I'm occupying, this is a case where approaching these things the way I would typically do, maybe at work or in other places, is very much not, is very detrimental. And I find myself needing to go a bit more off-road, which is, fun, but very different compared to what I'm used to. So it's kind of interesting seeing the pathway you're going on versus what I've gone through. But at the same time, what you're doing is very interesting to me, because engine development, you can make a lot of assumptions about what you're working with, right? And because you have a lot of assumptions, you can develop in a specific way like that. But when it comes to applications that are far more that you're managing a lot more stateful information and a lot of that complexity, these kind of things become much more alluring, right? Because like for certain game things, it's kind of like, for a game, it's one thing. Like there's one level of complexity. But if you're writing an application, for example, where you have like undo or redo or all this other stuff that's going on, or you're interfacing with other stuff, with other applications or server or whatnot, all of a sudden there's a lot more state information and state permutations that kind of crop up and need to be addressed, right? Mm-hmm. So this is actually very interesting within that kind of problem space, at least for me in my mind, right, in the application level. And I'm actually going to look into this a bit more. But yeah, it's like it's a very different, it's kind of interesting seeing how very different it is, where in one end, if you're trying to be super ultra performance, then like having rigid type structures for the data you're packing is very important, right? But that's only in the specific context where that is a real, like there's you saw that whole Casey Muratori clean code bad performance.
I think I've seen that, or I guess I've seen more of reactions to that, because I know it kind of got a little bit of hype, right?
Gotcha. Yeah. So you did a follow-up interview with Uncle Bob, where they talk more about this.
Oh, no.
Yeah. No, it was actually kind of insightful in some ways, because it seems like the general consensus that came out of that is like, yeah, there's places where if you realize there's a need for high performance, then you can do that kind of stuff and break those rules to achieve that, right? But by and large, there's a lot of places where that's not needed, and instead you can start approaching the problem in terms of like the conceptual, right, or in terms of the thing you're trying to model, right, as opposed to data first.
Right. And actually, I mean, what you brought up was a really interesting point that I kind of want to talk about too, is this is the other half of this. So I mostly live in the application world, like application development, business world, so I don't do a lot of low-level stuff. It scares me, so I don't. No, I mean, but this is another side to this thing, right? I've explained to you, oh, well, this is like you're kind of moving higher up the abstraction tier, right? Clojure is not a performant language. I'm not trying to make a claim that it is. Mm-hmm. I'm not even evangelizing Clojure. I just think the ideas in Clojure are interesting, but you can take these exact same things and you can literally do it in any language. Mm. But that's another subject. But think about, like, if we're talking about from like a data point of view, it is a really interesting thing what we're doing. And I don't know if I know another way to get about it, but after like someone kind of like points this out, this kind of really makes you think for a second.
Okay.
So we have types like integers, these primitive types, primarily because these types represent how it's stored in memory, right?
Yep.
But as we've continued to like build up these abstractions, these groups of types, these primitive types, we start labeling as like person or like nouns, right? They represent an idea, right? And then we get even higher to that abstraction where we're like, no, this represents a flow. Like this type represents an idea, like the monad type. Oh my gosh, right? It's not even concrete. It's just an idea of a type, right? And so somewhere along the chain, we've lost that type meant it was about how much data or how much memory it takes up, and more into these logical constructs. And so if we think about it, we could actually separate these into two different type systems. I've never really heard a lot of people talk about this, but we could. There's nothing that says we can't.
Okay.
Where you have one type system that is more about logical constructs, and the other type system is about the implementation for those logical constructs.
Okay.
And you can separate those things. And you could say, in a sense, you could even argue that interfaces are that thing. Interfaces are these logical constructs, and these other types are like the implementation of that. You could argue that, but I think it's kind of a shallow. It's not enough. Does that make sense? They don't play separately enough. They get confused. And again, these are just ideas. I'm not saying, hey, we need to do this, or this is how it needs to be, or I fixed programming. But I'm just saying, when you realize that types, like you're saying, they represent data and where it's stored in the memory, and we're conflating this idea with logical abstract concepts. When in theory, we could separate them. And so later on, if you're like, hey, I actually still have this concept of a entity in my entity component system or whatever, or my system, but I want to implement it using like bit packing. I don't know. I'm not a low level developer. I don't know anything, but you know what I mean? I'm implementing it differently.
Yeah, I got you.
Why can't you do that? Do you see what I'm saying?
I see what you're saying. I guess for me, the question comes down to what is the expectations, what is the problems these things are solving, right? Because for types, maybe it's what you're describing, where initially types were just meant to be kind of like, so like they outline the coupling of data, right? And then they kind of grew beyond that to be like an enforcement of how you interact with these things. And the utility comes into its like your static compile time checks, right? But I'm wondering what would be the explanation. What would be the specific? Like I would like to see a delineation between these two types of things, right? From the data-oriented stuff to this logical thing, and what is going to be the utilities those things are providing, and how that delineation is going to work.
Yeah, I mean, I don't know, but
No,
here's an example, right? Like,
Yeah.
let's go back to the application development.
Okay.
Let's go back to the person class or type or whatever. I want an ID for this person. Like, I'm talking to a business, to a stakeholder or whatever, and they're saying, yeah, we're going to keep track of people and we're going to keep track of their ID. In this in this discussion, you're not like being like, was it a GUID?
Yeah.
Well, what is it? Like, you don't know. Is it just like they have a special ID string? Do they not care? They want it to be an int? I don't know.
Yeah.
Like, at that point in the conversation, you don't care, right? But to them, they're like, okay, and what's going to happen is in our business logic, in our software, if someone has the same ending, or if they have this type of thing, we want this to do, like this to happen with their ID, right? And at that point, implementation still shouldn't matter. Like, you don't care if it's a good, you don't care if it's string, you don't care whatever. It's like you just have these ideas of, okay, that you have an ID and it can interface with another ID like this, and it can do this, and you can describe things from a very high level, right?
Okay.
In a sense, you're describing workflows. This is kind of the interpreter pattern that they get into. Gets all lispy, gets all weird, gets all Haskell-y, monads, whatever. Like, I've done a little bit of Haskell. I really like the ideas. I just think, again, since they're mixing the data space and the domain space of types,
Mm-hmm.
gets all weird sometimes. But at that point, it's like you don't really care what the ID is, and you shouldn't care. And so when should you care what the ID is? Well, when you go to like implement it, right? That's when you're like, oh, well, what should it be? Well, I think it should be this, and I think it should be this. But what if later they're like, hey, guys, we don't want GUIDs anymore because we want our IDs to start with our company name because that's cool and in vogue.
Okay.
Well, you should be able to be like, well, I can just change the implementation of the ID without affecting the entire business logic.
Okay. I see what you're saying now.
So this is kind of like the idea of, I mean, the original idea of domain modeling made functional or whatever by that book that was about F#. It's sort of the idea. It's just, I think we've never had languages that have truly separated these two types of logical types and data types. And I don't know if we should, because it could be a terrible idea for all I know. I don't know. Maybe it's awful. But we do treat them differently. Do you see what I'm saying?
Yeah, I see what you're describing. I'm trying to see. This needs to be a blog post. I feel like this kind of discussion or this kind of idea needs a blog post with some code snippets to kind of walk through this. Because what you're describing almost feels like two different levels of programming, where there's like this conceptual, which it's like this conceptual versus like the actual implementation level, right? And I feel like there's been things already that kind of do or try to attempt to do that from different angles, where you try to model just high level interactions and behaviors. Like there's even like it's a JavaScript world where there's like you could define behavior graphs and flows, and then that translates to actual code in some way, right? Or even like stateless stuff that exists where you define all the different types of states and transitions and what's permitted and what isn't permitted. I need to think a little bit. I would have to think more about what this looks like and the utility. Because like right now, from what it seems, static typing as it currently exists within what you're describing is kind of has too much responsibility on itself, right? And to separate it, the goal would be to separate that responsibilities up so they can operate within two different levels between the, let's say, business logic level versus the actual implementation level, or like the abstract level versus the actual real data representation of it, right?
Right. And I think...
Sorry. No, could you?
And I think this is why, to circle it all back, this is kind of where dynamic typing comes in, because dynamic typing is saying, I don't care right now.
Yeah.
Dynamic typing is saying, okay, you have an ID, I don't care what type it is, but you have an ID, that's fine. Right. And I'm not saying this is the solution. I'm just saying dynamic typing is just like, at the very least, it's not trying to make any claims at this point. In a dynamic typing world, you just say, no, I am just focused on if you have a good dynamically typed language. Because I think a lot of people, they judge dynamic typing based off of the worst dynamically typed languages like Python and JavaScript.
Yeah.
Instead of steel manning it with like Elixir or Clojure or Common Lisp, right?
Mm-hmm.
And so it's like, at least in this dynamic typing world, you're just working with these logical ideas. I have an idea, or yeah, these logical concepts, these abstract ideas. I have an ID. This ID can do this, and I can do this and this and this. But the implementation literally doesn't come until it fetches the ID from the database, because it's dynamic. It doesn't care, right?
Yeah.
There's trade-offs, and again, this is just like huge trade-offs. Don't get me wrong.
Well, it seems like it's kind of it's like it's coming to like this fundamental thing that's kind of always exists, where it's, hey, we want to be able to move faster and to think in this very human-oriented level, right? But on the other hand, we also want to have code robustness. We want to make sure that what we're working with is exactly what we think we're working with, and also we also want to have ease of debugging, both during development and post-release, right? And it feels like some of these things end up being directly counter to each other in some way, because you can move fast, you can have it where you have reduced friction to do stuff, but as a result, you kind of lose information that's required for robustness and better diagnostics. This is like takes, at least from my personal experience with dynamic languages, right? Maybe this doesn't have to be that way. It's just that maybe this is a matter of experience, right? I just haven't seen something that affords that, right? That doesn't sacrifice a bit of the other thing, right? Yeah, types are limiting, but I know exactly what I'm dealing with. I know what each function call largely is, right? And what to expect from it.
Yeah, and don't get me wrong, like, I think different types of dynamic languages should be in different categories. Because I would rather code in Java than Python. And that's saying something, right? Yeah. I'd rather code in Go than, I don't know, maybe JavaScript. I kind of like JavaScript. Don't really have a problem with JavaScript. Too much. But I know it has warts and all, but it's like the ubiquitous thing. Anyways, I don't need to go down that rabbit hole. It's like English, right? It's like English. Everyone knows it sucks, but everyone does it anyway, right?
Yeah.
But like with Clojure and Common Lisp, where you have, it's an introspective language. Like, you've heard of like REPL-driven development, right?
No.
So Clojure and Lisps, they run all backwards because they are backwards, right?
Mm-hmm.
In a normal program, it's like, okay, I create a new file, I've got an empty file, and I write a print hello world, right?
Yeah.
REPL driven, sorry.
Oh, REPL.
Yeah. REPL, right?
Okay.
Read, evaluate, print, loop. Oh, look, Clojure. There it is.
Yep.
Right,
first thing that pops up.
So in a normal program, you like type your program and then you hit run, and maybe it'll compile, maybe it won't, depending on the language that you picked, right? And it'll run your program, and you're like, oh wow, it worked, or it didn't, right?
Mm-hmm.
But in Lisps, what you do is you start your program before you even write a single line of code.
Okay.
That sounds crazy, but you start it, and it's just running. It's just going, right? And then you start typing some code in, and then you evaluate some code. And then you evaluate some more code, and then you evaluate some more code. And you're kind of working on this system live as you're coding. And if you want to inspect the state at any time, you can inspect it. If you want to pause it, if you want to go back in time, you can kind of do that in more Clojure than Common Lisp. But again, I'm getting to splitting hairs.
Okay.
And so this is why when I work in Clojure, I don't feel like, when I work in other dynamic languages, I agree, I feel like I'm losing information. Like, I have no idea what this could be, right?
Mm-hmm.
But in Clojure, I don't, because I'm working in the runtime. Like, there's not really a difference between compile time and runtime, because you don't work in compile time like other languages. You're actually working in the runtime. And so when you're working on functions, you're working on real data. Like real live data. And so there's actually a really cool story. Common Lisp, it was used in the 1990s for some space program, and they wrote it on this probe, and they sent this probe into space, and there was a problem. It might have been even the early 2000s. I could be misremembering the dates. And the problem is they figured out like something happened to this probe where part of the hardware, like of the hard drive, got corrupted, and these points of the hard drive were no longer accessible. And the problem is, if they restarted the probe, because they could access it like over the network or something, I don't know how, it's magic to me, but like if they restarted the probe, they were at risk of it never coming back alive, right? Because part of the memory on the hard drive was corrupted.
Yep.
And so what do you do? Well, fortunately, they had the REPL, and so they could connect to the REPL through space. It sounds crazy. And they could start editing the program live while it was running to make sure that when it would save memory, it would never talk to those addresses in the hard drive. Again, I don't get how this works completely because I'm not a low-level developer, but they were able to do this using common lists, and so they're able to modify the program live through space and fix it and have a successful space probe satellite mission or whatever it was, right?
Mm-hmm.
So this is kind of cool, right?
Yeah, that sounds really interesting.
It's a very different way of working. It's a very addictive way of working because, again, you lose some of these compile time constraints that you're used to, or compile time information.
Mm-hmm.
I mean, there still is static analysis, right? And that's really important. A lot of people think that you don't operate without static analysis. Static analysis is super important. It's important in every language. And so it will help you, right? Even if you're like not sure about something.
Okay.
But when you're working with the REPL-driven development, like I don't know if you've ever been here where you're like, hey, I've written this SQL. I don't know if you have to do raw SQL or if you use an ORM, but we still kind of use like Dapper. I don't know if you're familiar with like .NET Stack.
Nah.
Okay,
At least not for
so
that.
we kind of use this like pseudo like ORM where we like handwrite SQL, but it's like not raw SQL. It's kind of weird.
Okay.
And I'd love to be able to test this in my application at work. But what I'd have to do is I'd have to connect, like create my persistence layer, put the SQL in, I have to connect it to my domain layer, then I have to connect it to one of my handlers, then I have to create an API for it, set that up with a route, and so I can finally go into Postman and send it a dummy little thing and like, boom, did my persistence layer, did my SQL actually connect to my database? Did it actually work?
Mm-hmm.
Right?
Yeah.
That's kind of annoying comparatively to in a REPL. Well, I can just run any function at any time. And so if I want to see if one of my persistence functions works, I can do that just right there.
I'm kind of interested
So
of what because this is completely largely foreign to me. I mean, it almost feels like a more immediate version of not test-driven development, but kind of the way it pauses, where it starts before you write code. They say you first try executing it, get the error, and then you start working from there, right?
Right.
But it seems like a far more streamlined, continuous version of that. I'm kind of curious about I don't know, I have to look at this because there's other things that do that kind of behavior, but there's some different weird consequences that arise from it, and I wonder if it's kind of subject to the same thing. But the things I'm thinking about aren't, at least to my knowledge, like REPL, right? And they're written in languages that are not functional. So the mechanism by which they achieve that is very different from what I imagine is going on here. I'm interested. And if like what I'm talking about, one example of what I'm talking about is like Godot's scripting language and how works very well for recompilation on runtime and everything. But it seems like I might have to just look into this more before I make any comments about it.
they kind of say, again, I can tell you the downsides of Clojure and Lisp and all this stuff too. I'm not blind to it. Like, there's issues.
Well, REPL seems like something independent of those things, right?
It is. On one hand, it is, but on the other hand, it isn't. Because other languages have REPLs too, right? F# has a REPL, Python has a REPL, but the REPL works very differently because oftentimes when we say REPL in these Lisp-like languages, we're actually talking about a network-based REPL where you can connect to the REPL through a network. Why this is important is because now I can actually be in my editor and just evaluate chunks of code to my program, right? I don't have to go to the terminal, start the REPL, and type things in there. I can evaluate directly to my program or whatever.
Oh, so it's kind of like a LSP where it's just something that's continuously being fed, but instead of an LSP, it's just REPL.
Yeah, but you choose when you want to send the code, and you choose what chunks of code, right? So it's
Gotcha.
And so it's like, okay, I'm still working on this function. Okay, I've completed the function. I'm going to send this entire function. It will redefine the function and replace the definition in your program. And so anytime someone else or anytime another function goes to look up that function, it will be rerouted to the new definition of the function, and it will be able to evaluate the proper thing. And so again, at live, you can go and be like, oh, I've got a bug in my system. I don't want to redeploy because our deployment pipeline takes like 2 hours or whatever. I don't know. Depends on your company. But we can just connect to the REPL and we can modify the function just real quick, change this, and it will be good. We can make the change locally on our thing, and eventually when we redeploy later, it'll still have the change. All good, right?
Interesting. Okay.
It's sort of unique to Lisp right now. There's, like you said, theoretically, there's nothing that says this can't happen in other languages. Honestly, I don't know why it hasn't.
Yeah, because it almost seems like something kind of like not like the same like reactive extensions, but something. It's like it in the sense that it's a standardized idea that can be implemented across different languages, or it's like a specification that can be implemented across different languages.
Yeah,
that's what it seems like.
I think part of this. It's easier to implement in Lisp is because like the horrid syntax of Lisp that everyone cringes about.
Yes, I've heard of that.
Right, the parentheses, right? I mean, if you just look up some Lisp or some Clojure code, right? Like it's terrifying. Right.
Yep.
Sorry, I'm just watching you.
Yeah, you're good.
It's so terrifying. Oh my gosh, this is awful, right? Who can read this? Well, there's a reason to this. Lisp code is, I can teach you the syntax of Lisp code like in 1 second, right?
Okay.
I'm just gonna type in chat. The entire syntactic structure of Lisp is that.
Oh.
Function 1, so you have your function, so anything on the left or just on the right side of the first opening parenthesis is the function, right? So lambda is a function, right?
Yep.
Then arg1, arg2, arg3, and I'm oversimplifying some things, right? Because sometimes, again, if you look at Clojure, I actually think Clojure does a little bit better job with their syntax there. And I don't think any of that is Clojure right now.
Yeah, I was looking at Lisp directly. Interesting. But it at least supports multiple arguments, unlike Haskell, which is like one, and you have to use function currying to get multiple the behavior of multiple arguments.
Right. Clojure with the J, right?
Yep. Clojure, code, GitHub. Let's go to a random GitHub.
Yeah, I mean, I've got code if you want.
Ah, sweet.
But you're fine there. If you want to.
Does it work good?
I'll keep looking it up if you find one or whatever.
Yeah, whatever's first. Either I find one or you send me one that works. CLI Clojure. Okay, we got some code here.
Okay, yeah, this is great. It's the standard library stuff too. So it's definitely the more complex part of it, but it is part of the standard library. So
Okay.
this closure code, because they call this type of syntax homoiconic syntax, which means it's like one type of syntax, like one homo being one, icon, I don't know, like iconicity, like it's one way, right? And also in Lisps and Clojure, if you want to do a Lisp or a list, this is why it's called Lisp, you just put a little tick in front of that. So in the chat, I just put a little tick of 1, 2, 3, 4. And what you'll notice is this is eerily similar. You know what? Heck, I could even let me just stream my window if you're comfortable with that. I'm not gonna get you demonetized.
Yeah. Go for it.
Okay. Because it's best just to show you REPL-driven development and closure code.
Now look at the demo. Let's see this.
All at the same time. We're doing it live.
Oh, you're live already? Okay, I'm trying to...
Oh.
I didn't realize that was... Come on, let me watch stream. There we go. Alright, we're in. VS Code.
Let's see. VS Code, I have Emacs too, and NeoVim. I'm a mess.
All good, man.
So...
I'm a Vim person myself.
Gotcha.
Well, I'm not using Writer though.
Yeah, that's fair. Actually, why don't I do a mini closure project? Let's just do that. Use a random temp directory. Uh-oh, I'm gonna have to reshare this because it opened up a new window. Sorry.
All good.
Thank you, VS Code. Again, I eventually want to move to something besides this, but right now this is what it's at. Okay. All right.
All right.
Okay. All right. Now I have my REPL running, and so if I want to do my very basic 1 + 2, there it is. I know it's ugly. It feels weird. Especially mathematics can feel very weird in this syntax.
So
you're like, oh my gosh.
So the operators also count as function names.
Yes.
Cool.
So everything essentially is a function or a macro or whatever. But what's cool about this is, well, what if I want to add something more? Well, I can just keep doing this. Yeah, that's fine.
Okay.
You can kind of do the same thing with less than. This is going to feel even more weird. So if I have 3 and 5, right? Well, I know 3 is less than 5, but is 3 is less than 5, which is also less than 7? That is true, but is that less than 5 right there? That's false.
Makes
kind of
sense.
weird stuff,
Cool.
right? You can do this with an OR too, right? True, 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 false, right? This will eventually be true, but if I did an AND, well, then you'll get false, right?
Okay.
Now if I want to make a list, I can do something 1, 2, 3, 4. I've got a list. There's another way to do this. You can just do 1, 2, 3, 4 because list is a function name. That's cool. If I want to map that over another function like increment, now I've got 2, 3, 4, 5, right?
Okay.
But what you'll notice is the syntax of a list looks pretty much identical to the syntax of the language itself.
So wait, 1 second. So even in that statement, map is the function name, right? And then the first parameter is a function.
Yes.
And then the
So it
second
takes the
parameter is the collection you're working over.
Right. So
Okay.
this increment function is increments whatever number by 1. All right. And so I'm just saying, hey, map over this entire list and just increment it all by 1. I could decrement them all by 1, right? I could.
You can make your own
string.
function to operate over this too.
Yeah, I can make a
Gotcha.
little inline function, and what I want to do is I want to add 5 to each of these x's or whatever.
And that's like an
I'm gonna do
anonymous
it like
function there.
Yep.
Okay, cool.
Little lambda right
Or lambda,
there,
yeah.
and there's even a shorthand for it too. If I wanted to do this, which you can.
Interesting. Okay.
I don't love that syntax, gonna be honest. So I don't use it as much. I prefer this because it's a little bit more explicit to me. Okay, so this is cool stuff, right? And we can like iterate over some of this stuff, right? Do seek, which is kind of like an iterate. Like I'm gonna iterate over this list of 1, 2, 3, 4, and what I want to do here is I want to print X, right? It did print it. I just don't know where it printed it to. Did it print it to there? Where did it print it to? Oh, it printed it down here, I guess. This is where it's printing in a terminal. I'm not sure why it's doing that, but that's fine.
Okay.
Okay, right. That's cool, right? But also, this right here, this map, it kind of looks like a list, and if I just do that, all of a sudden it is a list.
So you can break anything down into a list.
Yeah, and because that's a list, well, I can actually get the first thing in that list, which is map.
Mm-hmm.
And if I get the last thing from that list, that's this portion of the list right here, right?
Yeah.
I mean, technically they have a second function too, so I can do that, right? And I could theoretically, I can replace that, right? Or I can iterate over it, right? Let me just replace this list with this other list. And now technically I'm iterating over each one of these things. So I can print like hello, and then here's the different arguments or elements, not really arguments at this point in my list. But if I wanted to take this again, right? I can, whoops.
Got him. Exposed.
I can evaluate that.
Okay.
So you can evaluate any type of code, right? Any type of list. I mean, I could technically try and evaluate this, but it won't work because this isn't a function. But if I just put a plus in there, that is a function, right?
Mm-hmm.
And I can go and modify. So what? All of a sudden, you're starting to blur the lines between what is actually code and what's actually data.
Yeah.
Because code is data and data is code in Lisp.
Mm-hmm.
And so if I want to make a macro, if I want to make something that can take in code and modify the code and produce new code and then evaluate that code, that's pretty normal thing to do in these type of languages. So this is like meta programming to like the highest degree, right? Like you can do that in like Rust, of course. You can make macros and stuff. You can make macros here. But it doesn't blur the line as much as it does now.
Yeah, this is pretty nutty. Huh.
So,
but I guess like there's some cool things that emerge from it. Like even just testing is actually far more easy now.
yeah.
Like, this kind of lends itself to doing that.
And this is how I do a function, right? I defined a function. My function, I can do 1, 2, right? And it's 3, right? And if I want to change this in here, I can reevaluate that and then reevaluate that. And so now it's multiplying. Ta-da. So, and so this is a live program right here, right?
Yep.
Technically, it is a live program. We started it just right at the beginning and have just been kind of building it out. And so eventually, if I wanted to like connect this to a database, I can literally check my database call or check a SQL statement against my database just by doing this very thing right here. I just have to pass in the reference to my database, right?
Okay.
In whatever SQL call I'm making.
Interesting.
So it becomes really easy. And so you know that feeling that you get when you start a new project and you're just working and just things are flowing and it's easy because you can just run and test it, right?
Yeah.
This is kind of the same benefit that you get in REPL-driven development. I can go ahead and like literally make a new file, right? And in this new file, I have a test function 2 or whatever, and this takes an argument, and this just adds 5 to it and returns it.
You ever done any kind of graphics programming at all?
Not majorly, but I know people I know Lisp's are huge into this, right?
Yeah, so this workflow you're doing, it feels exactly how it's like for me to work on shaders and graphics, and I really like it because it's very much the application's running continuously. I can go modify the code, it'll recompile and continue, like it'll recompile and run without having to stop the program or do anything. You just live see your code changes be reflected into the application, and there's
Yeah.
like I absolutely love graphics programming for that kind of workflow, and I kind of loathe anytime I have to do CPU code because it's not usually you're not operating with that kind of same level of fluidity, right?
Right. Yeah, and this is why this is like very addicting, this type of stuff, because you're like, oh, this is such a fun workflow, and you're telling me I can do this for anything, right? Or almost anything. I guess there's obviously areas that you probably can't do this with. But even game dev, some people use Common Lisp for, right? I did a game jam in Clojure. It was terrible, but I did. I wouldn't recommend Clojure for game jams, but you can. And so here's another kind of example of like duck typing. Just kind of let's say I want let's go back to our analogy of like I want to add 5 to age, right? This is a dumb function. I don't know why you would do this, right? But what I'm going to pull out here is I'm going to say, hey, I don't care what this object looks like, or what this object that you're passing in looks like. It's not really an object. They'd call it a map in Clojure, but whatever. This object that you're passing in, I don't care what it looks like. All I care is it has the age property. And I'm going to assign the age property to this age variable, and I'm going to return 5 plus age. Okay. That's cool, right? So now I'm going to create a few different structures, right? Now I have a dog structure. It's going to be named as Jack. That was my dog, and he's dead now. That's fine. Sorry.
Condolences, man.
And that was like a decade ago, so I don't know. I'm just making a morbid joke, right?
Yeah.
And then I have a person, and his name is going to be Joe, right? And his age is going to be 20, right? And age is going to be 20 years old, and his favorite color is going to be, we'll say blue, and his favorite dessert is ice cream or something, right?
Okay.
And also Jack, let's go back to Jack, and barks, we'll say true. And we'll create those two structures. And so now if I want to call the function add age 5 to age on dog, let me go back here. Did I evaluate this correctly? Oh yeah, I need to import it because it needs to know. Now why is it not working? Let me do this for a second. I think the syntax is this. By the way, I don't do this for work. I do this for hobby. So
Okay.
So if you want to see a hobbyist, this is me. There we go. 15, right?
Cool.
And what about person? Well, that's 25. That'll work. Well, what if I don't want to just add 5 to that? What if I want to update?
So, out of curiosity, what does this look like if you pass in an object that doesn't have that property?
Yeah, it'll.
Does it just
it'll
not
fail.
ignore it, or does it? You said it
Yeah, I'll
fails?
show you.
Okay, sweet.
Sort of. It depends. It depends on what operation you're doing. So, let's get rid of age here.
Yeah, because I was wondering if you have to do like an
person
accept thing on top of that to handle that case, or.
You can like add constraints if you want. I never do because all my programs work just the first time. Just kidding.
Beautiful.
But yeah, so this one's going to have a problem because it has you can't do that.
Gotcha.
But what if I wanted to do like I wanted to update the age of this person as I don't know, we'll say P, and I want to add 5 to that age. I think this is how you would do that. right here. I think that's how you do that. So now, all of a sudden, when I reevaluate this stuff, I'm getting back the entire data structure back. Which is cool
Interesting.
because now I'm able to add 5 to an age, and I don't care what data structure you pass to it. I'm saying, hey, I just want you to update the age and add 5 to it. I don't care what the rest of the data structure looks like.
You're kind of
All I
selling me
care
here,
is-
man. Kind of selling me here a
Well,
little bit.
There's issues. There will be issues, right? And you've just seen this one right here. Well, it's
Yeah.
like, well, this one doesn't have one, right? And so you can add more asserts. You can do whatever. You can try and add some guards here and be like, well, if it doesn't do this or do this, well, then in that case, do this, right? But I found, weirdly enough, because in Clojure, everything is immutable.
Okay.
And you don't run into a lot of the same issues that you would before, right? Just because I've done this to dog, if I go and reevaluate dog here, well, you can see right here it says 10, but down here it says 15. Well, why is that? Well, this is because it's immutable, and so when I'm making this structure, this update, it's doing it immutably and creating a new structure.
Is it allocating something new?
Sort of. I mean, you could, if you're getting into like the semantics of is it actually allocating a completely new structure? No, but you can think of it that way if you wanted.
Okay.
It's a really complex, it's called persistent data structures, where it's technically taking the old structure and kind of branching off of it and referencing like the old data structure, but then having an additional change on it. And so when you actually go to evaluate it in its new context, it will kind of collect that together.
So it's like, is it like kind of like diffs?
Sort
from
of,
the
yeah.
original data structure, and then it gets
Pretty-
compiled down to
Yeah. And that's
Okay.
how it's supposed to limit the amount of garbage that it's creating, right? Because if we just went around and created like new data structures everywhere we're going, that would be bad.
Yeah, I was gonna say like
Right.
I was like I wonder what the memory footprint looks for this kind of thing, like the
It's
memory
not
footprint,
good.
and then also yeah, because I was like I'm wondering if I try to do something a bit more intensive, like I wonder what emerges from there, right? Because like it's either gonna be like a large memory footprint, or you're gonna have very unpredictable memory behavior with, because I'm not sure like when allocation deallocation happens within like this kind of this language's specification, right?
Right.
Yeah, because is this like normally garbage collected, or is it using something else to deal with allocation?
Right. So
The
Clojure
allocation.
specifically is on the JVM,
JVM,
right?
okay,
The Java virtual machine,
gotcha.
which is a good thing and a bad thing. So this is a good thing because if there's any libraries that you need, well, Java has it, and you can interop between it pretty easily. And also the JVM's garbage collection is like top tier. Like Java generates a ton of garbage, so does Clojure.
Mm-hmm.
But it can get away with that because its garbage collection is actually probably the best in the entire world.
Interesting. Okay.
A lot of people didn't know that, but like a lot of people trash on the language itself. But the actual virtual machine is like incredible technology, right?
Okay.
And so it's kind of a double-edged sword. So let's go over the weaknesses of Clojure, right? The weaknesses are you have to get used, like it is opinionated. It is a very opinionated language. Commonly, if you're looking for a Lisp that isn't as opinionated, you can go to like Common Lisp, Janet, or Fennel, or Scheme, I guess. They're a little bit less opinionated. Scheme's pretty opinionated too, but like
Does OCaml fall within that same purview?
OCaml is very opinionated as well, but I wouldn't call OCaml Lisp, but I would say it is pretty Lispy sometimes, right?
Okay.
Um,
Because I feel like yeah, I don't know too much. I just know OCaml is functional, but it also has some stuff that's iterative as well. That seems
Yeah.
like familiar.
yeah, OCaml's a really cool technology that I've never really touched too much, but also since I've done F#, which is basically OCaml but Microsoft stolen, I have no reason to jump into it too much. So next is its performance. Its performance is better than Python.
Okay.
I would say it's in between Java and Python.
Okay.
I know that's not like glowing, right?
The different problem spaces, right? If your problem space doesn't
Right.
demand it, then why not, right?
But it's great for but it is really good for like web stuff. It's really good for concurrency, right? Because if everything is an immutable data structure, well, you're never actually running into any issues with concurrency ever.
Mm-hmm.
And that's kind of a crazy thing to think about. It's like, well, how do you maintain state? Well, it's you have something called atomic variables. And atomic variables are complex, but they're really easy to use. Like I can just show you, like here's an atomic variable. My var is going to be an atom, and it's going to contain hello in there, right? And if I wanted to reset that atomic variable to goodbye, I can do that. And if I want to see the value of it, I can get that. There's a whole bunch of, like, this is a whole nother complicated subject in itself. You're like, that's just a complicated way to do variables. Well, the thing is, this is like threads, like not just thread safe, but it's like impossible to have like deadlocks. It's impossible to have like concurrency issues with this. And again, you can read more about atoms and how they work. And I mean, the idea is they are optimistic. It follows an optimistic concurrency model.
Okay.
Where like read, write, locks, and mutexes, they are a pessimistic concurrency model, which are saying, hey, I'm going to make a change, so I am blocking anyone out from even accessing this, right?
Mm-hmm.
That's what they do, and then they make a change and say, okay, I've released it. Now someone else can access it, right?
Yeah.
But optimistic means anyone can actually write to this at any time. But what happens is after the write, it will immediately check to see if the atomic variable is the correct value it should be after the write time. So if two things write at the same time, one of them is going to write and one of them is going to win. And if theirs is correct, that change will be sustained. But the other one, what they'll do is like, oh, it actually didn't work because someone else wrote before I did, before I could check it or whatever. So I'm just going to do it again.
Okay.
So it's an optimistic model. And so if you have like 5 things trying to do it at the same time, one of them is going to work, then the next one will work, and then the third one will, and fourth and fifth, and they'll all continue to retry until they get it all right. But they're not ever locking each other out. Does that make sense?
Yeah, it's
So
the end result almost feels like the behavior is like a key, right? Not like it's actually stored in a structure like that, but the end result is a behavior kind of like that.
yeah.
Okay.
Yeah. So this is kind of how they do this, and so because everything's immutable, you can do fearless concurrency. I know they like say that in Rust or whatever, fearless concurrency. Do they say that in Rust? I don't know.
I don't know. Well, Rust has a bunch of different options for concurrency.
Right, like Tokyo or whatever.
And also like the actual structures that you wrap with them in. So you, like you said, if you want to use pessimistic structures, they have it. Like they have ref, cell, read, write, lock, mutexes, all that kind of stuff. And then I imagine they probably also have some more optimistic ones available, like you mentioned.
Mm-hmm. Yeah, and I don't know if they're like optimistic is more performant, but it is more stable, right?
Yeah.
You're not going to run into locks, right?
Yeah, there's
locks.
overhead from it, but in most cases it's kind of negligible. And
Mm-hmm.
if that performance is a consideration, then there's bigger things that they cause issues with.
Right, and so like this is another one of those things where it's like concurrency is like great with Clojure. It's actually not even opinionated about concurrency, like so much so that like, because so this is kind of the thing with Lisp. They call it the Lisp curse, right? Because you can modify the language using macros and whatever, and it's so easy to do this that everyone kind of creates their own libraries.
Mm-hmm.
And if everyone creates their own libraries, it's kind of hard to find standards. Now, Clojure is a little bit of an exception to this. There's a lot more standards here. But there's, like, literally, I think I saw on the Reddit this morning of Clojure just put out their own async await style of concurrency. Now, most people don't do that. They actually prefer the Go style of concurrent sequential processes. Like, I don't know if you're familiar with how Go concurrency works.
No.
It's like channels.
Okay.
Just channels and Go routines or whatever they call them.
Yeah.
In Go. So channels and coroutines, that's kind of how Clojure typically does it. But if you want to do async await, you can just pull in that library. If you want to do an actor system, you just pull in the library. So it's unopinionated that way. And so things that you would think would be really core to a language are actually not core in Clojure. They're just like, yeah, it's just a library, and if you want to bring it in, it's a core library. That's what they'll call it. They'll say it's a core library written by the maintainers of the language, but it's not required. Or you don't have to do concurrency this way. It's up to you. And so again, this kind of creates a weird culture where it's like, okay, you can run into. So here's really the biggest double-edged sword, which is why I don't know if I'd ever want to work in Clojure. Is because whenever you're writing code in Clojure, you're kind of tailoring the language to whatever you're doing and how you think personally, because you can.
Yeah.
And that's a problem when you get into a code base that you've never seen before.
Yeah.
Because you're like, what is going on? Like they're doing something crazy that I have no idea how they just pulled this off. Where like Go, one of the selling points of Go is like there's only one way to do things, right?
Yeah.
Well, Clojure's like, no, however you think you want to do it, that's the right way to do it.
Well, that's kind of I mean, it's kind of going back to the top of the stream, I guess, or the top of the talk, right? Was that you started from like these solid, like you're indoctrinated into these solid principles, and what I've kind of come to realize is that these principles are less so about pursuing what's actually absolutely best for this circumstance, and it's much more, from my own experience, it's much more of a treaty, or it's much more of a compromise, so you can enable co-working with other people, if that makes sense. Or at least that's the intention, it seems like. Where it's like, hey, this is not the best, but this is how we're going to manage complexity so that you can interop with other people and work with them. Which I get, but at the same time, it can work, but I don't think it honestly achieves that end goal most of the time or all the time of making interfacing with other people easier, right? Like there's this whole idea where there were communications like the biggest cost when it comes to programming, right? And adding an additional programmer to your team doesn't inherently an extra programmer level of productivity, right? Like if you're at best maybe like 1.8 or 1.9 level boost of productivity if it's really, really good, but realistically it's much lower than that. And I find myself that by using these principles, it just kind of creates additional complexity that makes it introduces far more structural complexity that it makes it harder for any one person to maintain that entire state in their mind, right? So it's interesting that this can also suffer from that same consequence, but from a very different level. But instead of like instead of unnecessary complexity, right? It's much more that arises from specificity in terms of the whatever problem you're tackling, right? Like for the people who are like people at company A who are doing things within a specific problem domain, then they'll make the macros and whatnot for lists that makes this way easier to work with and streamlined, which is great for them. But then, like you mentioned, any new person that comes to there, instead of like that not skill ceiling, but that difficulty of adaptation is a bit higher in the beginning now because of that, because you're entering this kind of new world. That's kind of like the same stuff that happens to like C and C++ macros too.
Yeah.
But that case, I get that price is much more beneficial, right? Because the complexity introduced from solid principles isn't really for any benefit, right? Whereas there's tangible benefits to it. It's just that there's much more. That's the price you have to pay to get to that, right?
Right. Yeah, no, it's true, and like macros are cool. I don't know if you've like dug into the world of macros much, and like they're like intoxicating in a good and bad way. I don't know how to explain it better than that, but like Like if you want something that is self-registering within its own file, but I want to register it to like the core function or core main function, you can do that in a macro. Right? And that's cool. So you can all of a sudden start and make your own framework or whatever. And it's like, oh, I want to make a new file. And then when I just define this and put it in a macro, I know it's going to automatically be registered. I don't have to go and register that to a greater file. And just like, that's just like one of the most simple macros that I think are common. But you're right. Like it's kind of a death by specificity, sort of. Kind of creates issues. And again, I'm not saying, oh, I'd never want to work in Clojure. If someone offered me a Clojure job, I would probably take it because it'd be cool. But I would be a little wary, I guess. Like I would want to be like, okay, well, do you guys have problems in your like code base? Like I try and ask some questions to see the engineering culture as well. Because if the engineering culture is bad, with unlimited freedom, I don't know. I don't want to know what type of mess was made.
Yeah.
Right. So I'm not trying to pitch to you Clojure. I'm kind of almost trying to pitch to you like, hey, this is it. What are these ideas that you can learn from Clojure, and take this and apply this to whatever language you're working on. Like trying to work off of data first, trying to work off of just very simple ideas of functions, data, immutability first if possible. Obviously if you're in like the game dev world, all this stuff gets thrown out the window, but you know what I mean, like just some of these ideas, interactive, like time to feedback, because truly when we're talking about why people like compiled languages is not because they love compilers. It's like, oh, I love compilers. No, you don't care about a compiler. Well, maybe some of you do, and if you do, like that's fine. But like, what people like is instant feedback. They like typing something in and being like, oh, it's a string, not an int.
Yeah.
And they like knowing they made a quick mistake to make that quick change. And so instant feedback is truly the name of the game for developer experience. And I don't know if you worked on like a huge, massive project where the LSP just sucks because the project's too big. Like, why do I even have an LSP, right? Like, it doesn't work anymore. That instant feedback is gone because now if I ever want to test it, I have to compile it, and that can take like 7 minutes. And I'm kind of explaining what I go through at work every day. 7 to 10 minutes to like recompile my entire project, and my LSP is broken half the time. And so the benefits that I'm getting from a statically typed system is starting to limit itself.
Yeah.
And so what I really want isn't static types necessarily. I mean, they do have their benefits, but what I want is feedback. I want to know when I made a mistake. And so you can kind of do this with Clojure. It's like, okay, well, does that work? No, that literally didn't work. Why? Is there something wrong with my function? No. Is there something wrong with the data? Yeah, there is. It's missing an age, right? 200. And you can go and say, all right, well, that should never happen again, so I can go and add an assert or whatever if I want, and be like, yeah, the age needs to exist or whatever. And this kind of instant feedback way of working, it's like, well, you don't really miss types as much because you're still getting feedback. Do you see what I'm saying there?
Yeah, I'm getting what you're saying.
So, anyways, this has been long-winded. I've taken up way too much more of your stream than I ever expected,
Hey,
so
man.
I apologize for that.
It's all good. I learned something new from this at the very least, though, and I'll probably go to my my coworker tomorrow and bring this up to him.
Yeah.
This REPL stuff. Yeah, cause
Cool.
Yeah, no, because it's kind of interesting. Like for my day job, right? It's VR, and it's in a very intensive application, right? Even within the scope of VR, but even then, there's kind of a stratification in terms of performance-intensive stuff and things that are not performance-intensive but are managing and dealing with so much state information across like multiple different places and across different contexts, where there in those cases, in those places, we're perfectly fine like sacrificing some like performance in favor of managing that complexity. How well we're doing that's a different story. But the surface area that we're covering with that is it necessitates thinking about things very differently, or thinking about these problems very differently. So this is something that definitely worth considering. I know for us in general, we've been implementing some stuff related to that kind of thing and exploring different ideas related to that, from stateless to actor model stuff. Reactive extensions is a long thing we've been playing around with to deal with this kind of stuff. But yeah, this is interesting. This is definitely super interesting. Even if we don't end up I don't even end up using Clojure for personal projects, at least for playing around with or you exploring these different ideas, that might be very beneficial. Yeah, I need to check this out, man.
Sweet. I'm glad to hear. I'm glad it helped. Yeah, I definitely think I come from a different world. So like, I don't know game dev. I don't know any of the stuff. VR stuff. That's like mind blowing to me, you know. And so that's some cool stuff. So I don't know how much it could help, but it is just a different way of thinking. And so, anyways, I appreciate the conversation. It's been fun.
Yeah, man, I enjoyed it. Super educational.
Yeah.
Heck, I think even like Rust has a lot of functional support, so maybe a lot of these things we talked about can actually be applicable there too.
I think it could. I think if the question is, can Rust do it? The answer is usually yes. Should Rust do it? That's another question. I don't know. You know what I mean?
You have to find out. Yeah.
Rust can do anything, right?
Yeah, it can. I don't know. There's a like you mentioned at the very end. There's like this joy. There's a other component that's like the joy of programming, right? Or at least the feedback loop of programming, which I think that feedback loop ties into the joy of programming. And the more I work in Rust, the more I'm rubbing against more and more different things related to that. But outside of that performance bubble, that's a different question. I think the friction's far less there. It's far less there compared to what people think. I know when most people used to hear Rust, they're like, "Oh, you're gonna die, right? Trying to implement something in there, or trying to learn it."
So what do you mean if you don't mean like the implementing something? Where are you talking about the friction then?
The friction. Well, friction at what point? Well, like if I'm getting out of that performance intensive context of Rust. Like, you're talking about where the friction lies within that context, or are you asking why the friction goes away outside of that context?
Right. Why does it go away outside of that context?
Oh, because in the frictionless context, or the performance context, you end up having to do unsafe Rust. So you have to go off-roading and doing a lot of stuff and managing allocation, deallocation by yourself. You don't have any of the guarantees, which in some sense is kind of nice because then you can be more expressive. But the language doesn't like you doing that, and the syntax, how should I say it? There's less things that you're going to be working on and relying on for that, right? Whereas outside of that, you pay a price of things being a bit more verbose and having the borrow checker working against you, but you have the whole development pipeline is kind of catered towards that, right? So at the very least, you know what you're writing is going to behave as expected and whatever, right? Whereas in this other context, there's less things that you have at your disposal, right? So like even the async stuff that we talked about, there's structures that exist in safe Rust to handle that stuff. If I want to deal with it, I could just say, hey, I'm going to use the things that currently exist for it. I can just wrap my stuff within the atomically reference counted structure that contains a read-write lock and use it. And sure, code might be a little bit more verbose, but I have these guarantees to work with, right? Whereas in the more performance context, you're saying, I'm going to take charge of everything. So there's like two levels, right? There's there's less things you can work with. I can't draw upon those things. If I do, there's more things that can come up as a result of working with them that's not going to be documented in any way, right? And the second thing is the syntax gets a little bit more funkier. Whereas in safe Rust, you have just a simple understanding of safe references versus unsafe references, or not. you have your idea of references that can be either mutable or immutable, and you're just working with those confines, and that's fine. And then they have their way of working with stuff. Whereas if you go off-roading, there's this weird syntax for pointers that doesn't really express what they're doing very clearly. Whereas if you use C or C++, or the pointer stuff actually feels much more intuitive to work with compared to how Rust defines them, right? So it feels weirder. So I guess maybe my statement wasn't as specific, right? There's kind of a trade-off where unsafe Rust can be a bit less verbose, but what you're actually doing feels less like just looking at the code, it's a bit harder to understand what exactly is going on based off the syntax. Whereas safe Rust is much more verbose, but the rules seem very consistent and it's very easy to assess what you're doing there, right? Does that kind of answer your question?
Yeah, it does. I don't think I've heard much of, like, I don't think I've heard a lot of people try and, like, go into unsafe Rust that much. And so maybe this is why I haven't heard this experience a lot, just because.
Yeah,
I don't know. I feel like if you're going into unsafe Rust, you must be doing something that is, like, crazy. And I don't mean in a bad way. I mean, like, this is like really intensive stuff.
So it's like I've written this engine, like it's gone to like basically 3 fundamental different iterations. One where I was still learning Rust and I did everything stack allocate, or not heap allocated, and we just boxed bunches of different stuffs. And the second round was, okay, we're gonna actually do this in a more idiomatic way using atomic reference counting, all that kind of stuff, and just using the structures that Rust tells us to use, and that works fine. The second iteration is, okay, we want to do some optimizations. We want to have memory that's very contiguous. We want to do, instead of structures of array or arrays of structures, we want to do structures of arrays instead. And we're going to have mutability be passed in different ways to better allow for that. Hello, this is John, by the way. John? Like, which John? Wait, John Linsner? My guy? My goat? What's good, John? But, yes, okay, cool. I had to go through a list of different Johns I knew in my grade. Sweet. Yeah. But going back to what we were talking about, but this guy, John, in chat, he taught me so much, dude, at my job. He's super sick. But yeah, so like, in this third iteration, I guess that's not a very specific name. I saw that you're live and wanted to see what's up. Yeah, dude, we're just chilling. I was learning some functional stuff today from, I don't even know your name, man. You just hopped on to stream and. Yeah,
I'm Trevor, or
Trevor.
Tofu, however you want to, whatever one you prefer, I don't care.
Yeah. Yeah, just a recontextualization though. We were talking about he was showing me some cool stuff about Clojure, about some ideas related to REPL, and like different ideas of modeling, how you model data, and the second idea of having immediate feedback to your code, where like graphics programming is really fun for me personally, because then you can write code and see it be recompiled and see it happen immediately, whereas CPU coding doesn't feel as fluid to that, and this almost seems to try to achieve that, or seems to achieve that in a different way. And now we're going back to this Rust thing, right, for this third iteration of my game engine, which, yeah. So like I was mentioning to you, where did I left off at actually? Do you remember at all, Trevor?
Yeah, you were talking about how you were, because I asked the question and I'm like, oh, why are you doing unsafe Rust? Essentially, like in a nice way.
Oh yeah. Yeah.
You're
So
saying
like,
that you. Yeah.
No, continue.
Go ahead.
Yeah, so like there's this whole thing that I started looking into for data-oriented programming, right? And I realized that using just the structures that Rust offers for you actually kind of sacrifices a bunch of different things. So like there's the idea of like optimizing for cache, right? And when you're using these when you're wrapping all your references within the Rust structures, like atomic reference counted structures and whatnot, or ref cells or whatever, you're kind of, and you have like a collection of objects that are just like let's say an array of these reference counted things. They're not really nice for cache, for cacheability, right? Are you familiar with this at all? Like,
I'm aware of like the idea of ref cells and atomic reference counting like types or whatever, but I don't know what you mean by like it's good or bad for caching. That doesn't make sense in my brain.
So let me bring up. Let's go to Miro real quick. And I'm not an expert at this at all. I'm just getting into this. Like I saw like a couple different people rant about or talk about this. I saw John Blow talk about it and talked about how even just simple just a simple object with the interface is already drastically slow, and that's what prompted his language, right? They're both kind of symptoms of that idea of cacheability. So let me just talk about memory. I think I even had this talk already before. There's a stream when I was kind of talking about this, and someone came with their project that was not working really well, and we kind of got to talk about that a little bit. I don't think I have it here available. Okay, we're gonna do the diagram from scratch. So you have a computer, right? So your computer has a CPU and it has RAM, right? Is that fair to say?
Yeah, that's fair to say.
Your computer has those two things. Sweet. So let's draw a little diagram. Let's say you have your CPU right here, and then you have your dedicated WAM right here. And I imagine you also may or may not have a hard drive or a SSD or something like that. This is like my favorite performance topic. Dude, I'm just getting into this. I started tasting the Kool-Aid of this, and I started doing that with my game engine, and like, oh my goodness, data-oriented feels so much more easy to work with, actually. And also, it's cool seeing the crazy benefit that arises from it. And like, so anyways, yeah, and that's why I'm like, this is part of the reason why I went through this full circle of learning Rust, idiomatic Rust, unsafe Rust to get optimizations, and now I'm like, I just want to do C, and now I just want to do C or C++ at this point because I want to have that freedom. Anyways, so let's get back to the diagram. So you have CPU, you have RAM, and you said you have a hard drive and or SSD, correct?
Yeah.
Is that correct? Okay, cool. So your SSD or hard drive, whatever you would like it to be. So these things kind of, we could think about them as living on the same street, but at different distances. So like, we could say like CPU is, where you live currently. And your RAM is like, I don't know, down the block, down the street, a couple of like a couple blocks away, like a block or two away, right? And then your hard disk drive is like, I don't know, a different area code away. You gotta drive for that sucker.
Right.
And in fact, there's a guy who made an even better description of this, so I can send you a link to that if you're interested. So let's say you're executing a program, right? And your program is most likely gonna have variables, correct? That would be ideal.
Right. Yeah.
So that variable may be accessible in different ways. Your CPU is like a chef in the kitchen. He's cooking some stuff, right? And he needs to have the ingredients he's working with there. And the ingredients in this case may be a variable. So, or just let's make it even more abstract. Just not even a variable in your program, just data, right? So if you have to go from your CPU all the way to your hard disk drive, that's a long distance. That's going to take a long time, right? That's as if the chef had to leave the kitchen and drive all the way to the farm to get the chicken and get the eggs from the chicken, and then drive all the way back to home or to the kitchen to start working with that, right? It's pretty slow. And then as you make a program, it's going to allocate different stuff to RAM instead. And that's a bit closer to your CPU, right? So it's still a distance, and it's still probably not ideal for the chef to have to go a couple of different buildings down to be able to access like an ingredient he has there. So what would the chef do, right? Instead of, let's say, like going to the supermarket, right? Well, normal chefs in most operations aren't going to the supermarket every time they need a certain ingredient, right? What do chefs do instead of going to the supermarket?
I mean, if they buy a ton so they can bring it back, is that what you're getting at?
Yes, that's exactly where you. Thank you. Yeah, so a chef, they're like, you don't just go to the supermarket every time you need something. No, you kind of put it in your fridge, right?
Right.
And if
okay.
it's too much in your fridge, they may put it in your pantry, but you keep it, you buy it, you put it in your kitchen, right? So this is kind of what cache is. Your CPU has something called cache, and that's effectively kind of like your fridge. So when you're executing a program and you have a variable, that variable is going to live in your RAM in some way, right? Either in a stack or heap, whatever, right? Your variable exists there. And as you're executing the program, let's say you call a function. In fact, let's do a quick code example of this. 1 second as I get. Oh my goodness, why is it not responding? Is my keyboard not happy that I've been not using it for a lot of this stream? Okay, there we go. PowerShell. So let's go like to a simple program idea that you probably. It's a language largely agnostic. So you probably have like, I don't know, let's say class, whatever. I don't know. Class Bob. I suck. In fact, why didn't you just do this in C#, whatever. And he has a variable, whatever, private, int, we're not worried about that. Integer, I don't know, age. And he has a function that does something to age, right? Mutates it, whatever. Increment, like in your example. And then he just does age plus plus. So in this example, if you're executing for the first time, your program is going to run in your CPU, right? And it's going to say, hey, it's going to get to this line, line 12, and it says, I need to do something with age. I need to get it, and I need to do something with it. So your CPU has to go all the way over here to get this variable from RAM, then bring it back over here, and then it's able to start operating with that. Does that make sense so far?
Mm-hmm.
Now, something kind of cool happens. If you call this function again, your CPU is not gonna, your program's not gonna do that. It's not gonna go all the way to RAM, because instead it stores it in something called cache. Now cache is like another form of memory that lives very close to your CPU. And if you call a function that has some data that's relevant to it, it's gonna be stored there. There's some other stuff that goes on to what gets determined to be stored there or not, but we're not gonna worry about that.
Yeah, I kind of vaguely remember a lot of the stuff, like the LRU cache or whatever.
Yeah, and there's,
but it's been a while.
It's all good, right? So like, cool. You call that function once, it's here, and if you call the function again, it's gonna be like, hey, wait, I have that right here. We're gonna use that instead. And all of a sudden, you don't have to go all the way over there. You can just grab this from here. Now, let's say you call something else. Let's say you access some. There's another data. Let's say, I don't know, string name. And then you have another function called getName. It returns a name. So okay, we call this function, Bob's age is in cache right now, right? But then the next iteration, we call getName. Oh, that's not in cache. We have to go all the way back to RAM. get his name, and bring it back here. But what happens if there's no more space available to put name in here? Well, that's called blowing cache. And then we get rid of this and put name there instead. Cool, and now the next time you call function 2, get name, it's already there for us. But what happens if we call function 1?
Yeah, then I'll have to do the same thing.
Yeah.
Blow the cache.
So that's the thing, that's kind of behavior we're kind of working around with, right? So this is kind of a simple example, but let's say imagine a scenario where you have a game that has like thousands of entities, right? So we have like a class, enemy, and they have a bunch of different things. They have position, they have, I don't know, maybe an ID, names, whatever, right? And you have to iterate through a large collection of them. Let's say an array of like 1,000 enemies. So if you have to, let's make this enemies. So you have this large collection, this large array of this structure called enemies that lives here. Now, if you're like in a game, there's a bunch of different kind of update cycles, right? You might have to load stuff in to do physics, and then you might have to load them up to execute logic, and you might have to load them up to do some rendering stuff, right? And let's say there's a multiple different collections of objects. Like you have an enemy, but maybe you have some other stuff like, I don't know, environments. That's also like 1,000 of them or whatever. Or some other object. Well, it's very inefficient to load all these enemies, do like one thing on them, and then get rid of them just to load this other object, right? Mm-hmm. Super slow. You're blowing cache and you have to keep going back through it. So that's like one issue. So I'm actually going down one pathway. We were talking about Rust and we were talking about reference counting, right? Let me go back, change this example back to there. Sorry, it's not the best thing. It was kind of impromptu. So
no, you're good.
So we have this enemy, right, structure, and we can have an array of them, and we can assume that we have this array with 1,000 enemies, and they're all located together in cache or in memory, right? So you can load this block of all the enemies into your cache and do stuff with it, and they can exist easily there, right? They exist as like one unit. But let's say instead of having an array of the actual class itself, you're instead having an array of the references instead. So in Rust, it'd be like arc enemy, atomic reference counted enemies, and there's 1,000 of them. Well, you get this. So now instead of enemy, we have this arc. So now instead of loading all the enemies, you instead load the references to do stuff with, right? But what happens when you try to get the data in there? It's not actually in here. It's still somewhere in RAM. So you still have to pay the price of going all the way back to RAM to get the concrete instance of that enemy to process it then. And then when you go to the next iteration, you have to do the same thing and over and over and over again, right? So there's that hidden cost.
That's always going to happen with a ref cell or an arc because by nature it is a boxed type, so to speak, right?
Yep.
Right?
Yep, exactly. So that's like one of the hidden costs of that, right? When you're using atomic reference counter or any kind of reference counted structure within Rust, you're always going to be wrapping them within that. And that means that every time you load it, you're going to be kind of ensuring yourself a cache miss, which sucks in a performance critical context, which is why I had to go through this whole thing of unsafe Rust. Because now I want to be able to pass an array of just enemies that are contiguous in memory and modify them, but references, but Rust doesn't want you to do it like that. It doesn't want you to have access to them in that kind of way, a bunch of stuff. So hopefully that kind of explains the necessity to do unsafe Rust for more performance critical things.
Yeah, I guess that totally makes sense, and even just thinking about this, I didn't even realize like and not saying that's a huge performance hit for regular applications, but like I see a lot of people just say, hey, use clone and use arc everywhere, right? Or RC or whatever. And like that almost just feels like you're coding in C# or F#, I guess, at that point.
Yeah, well, in a weird way, you're kind of doing, because C# does something kind of like that. The thing is, Rust makes it far more explicit that you're doing that, if that makes sense. I mean, it's kind of different. I think the cost for Rust is actually a bit different, because C# is operating with a garbage collector, whereas the reference counting structure is fundamentally different to that. But yeah, it makes this kind of behavior a bit more explicit. But yeah, that's one thing, and then yeah, there's other things that emerge from it, but at the very least, it kind of shows that cost of that. If you're interested, though, there's a very cool talk Jonathan Blow made about. He's writing a custom language called Jai, and it's meant to be very data oriented, or at least afford itself to data orientation, while still offering some of the things you're kind of familiar with other object oriented languages. And in his talk, he kind of goes over a similar kind of use case that shows like, hey, this is a thing we use very often, and it's very easy to go for it. I mean, it's very convenient. That's the way we think about it. But here's kind of the cost that kind of emerges from this at scale, right? So, yeah, it's pretty interesting stuff. There's actually a bunch of talks about data orientation. But yeah, and that's like, you know, it shows, it kind of explains some of the stuff that we talked about earlier too, where, oh yeah, we can't, like for high performance places, you don't want to have structures that are variable in size, right? Because then you can't have them be contiguous in memory next to each other if each instance might have different data, right? But I think you're gonna say something before that.
Yeah. So why C, like, why not like Zig? I know Zig's getting a lot of hype right now this year, especially. Primeagen has a lot of influence over the programming world.
No.
And yeah, why not like Zig or right now, or even another one of them? I'm just curious.
I mean, Rust is just, I was tired of C#. Because like during that time, I was doing C# for, that doesn't explain why Zig or whatever, but it wasn't as in my purview. But during that time, I was like, I'm doing C# 8 hours a day for work, and I'm doing C# for another like 4 or 5 hours after work, and that's still kind of the case. But at that time, I was like, I need something that's radically different from C#, something that feels fundamentally different. And Rust seems to be like the most, at least one of the most different things, while still conforming to like, you know, some object-oriented ideas. If I really wanted to go super different, I could have gone functional, but functional seems so crazy.
Yeah, functional. It's easy peasy. It's whatever.
Yeah, and then Jonathan says
it's good in different ways.
And Jonathan said Zig looks interesting, but C++ is just comfy for me at this point.
So yeah. I guess what I mean, like, because you're saying you're kind of getting disillusioned with Rust because you're having to go to unsafe anyway. So
yeah.
And so you're like, well, I'll just go with C or C++. And so what I'm not saying is why not Rust over Zig or Zig over Rust. I'm saying why not Zig over C or C++.
Oh, so like as for like when I make Engine 2.0 or 5.0 at this point, right, in a new language, why not that stuff?
And I don't know Zig, by the way. I'm just curious.
No. And actually, I was thinking about that because the Primeagen recently, or not recently, but a couple months ago, also switched from Rust to Zig. And Zig looks interesting. There's some cool, powerful stuff it does. I know when it comes to macros and preprocessing.
Like comp time or whatever they call it. It's pretty cool.
I think the reason I want to do C and C++ is kind of like two-pronged. So the first thing is that like it's hard to appreciate the problems Zig and modern programming languages are solving without actually going through what spawned them, right, or what kind of initiated it. So I think working with C or C++ is going to help me like understand this landscape a bit better, or at least understand the reason behind these languages. The second thing is like these languages aren't really super battle tested yet. Like they're being used for production code, and there's still a bunch of stuff that's being like developed, and it's cool and interesting, but there's still, this jury's still kind of out. Whereas like if I know C and C++, there's a wellspring of places where I can use it. There's a wellspring, a bunch of projects and repositories that use it and that can interface with it. And regardless of what language becomes like the de facto, hey, you got to use this for low level in the future, there's always going to be some kind of persistence for C and C++ in a bunch of different places. So I think like for me in my position, it's just beneficial to learn how to use C and C++. Likely, like I said, C++, but you know, just with like operator overloading. Yeah, and then like C, I actually did C stuff like a long time. I started with C++ a long time ago, and then I've always been doing things here and there, so it doesn't seem as foreign. The only thing that I dislike about it that Zig almost gets me is the build system, and that's the thing I still like about Rust is how easy it is to build things. Like having to learn Make or CMake and work with that stuff is like the one biggest rub for me, right?
Right.
Because like it just, like we talked about, we like having that iteration. I don't know. There's something about like it's very easy to not only build but also do dependency managing within Rust and even like Zig and or other languages like that, right? Whereas that's the one thing that still bothers me when it comes to C and C++ is that either I'm gonna have to do some funky stuff or I have to learn something fundamentally different to get it working, right? And that's not the biggest, like that's not the end of the world. Like I started working on a baby version of my current engine in C, but I know as it grows in complexity, it's going to become much more of a rub for me. And if I decide to do like more, like cover much more like other platforms, right? It becomes, I foresee more stuff coming from that, right? Like it's fine now because I'm working just for my one singular laptop on this one particular use case, and it's mostly for my own edification. But let's say I want to start branching out to other stuff, I know it's gonna become much more complicated. Whereas like with Rust, it's very easy to get my code working on Windows, Linux, whatever. If I want to do WASM, I can do WASM compilation. There's already infrastructure that exists for that. Whereas right now, I don't know how that would look like if I did that in C, or C++. But that might be that might be the learning arc for me, right? That might be the thing.
I was just curious because, like, for me, like, I had to do C, excuse me, and C++ in college, and I didn't have a problem with it back then, but I think I've just gotten so accustomed to, like you're saying, the niceties of the build systems, the CLI tools, where I can just do whatever, cargo make or, you know, or cargo build or cargo run. I don't even use Rust, so, but you know, the modern stuff, right? So,
yeah.
And so I'm just like, I don't actually have any idea how C works or like the build systems and CMake. Like I get it, like I've ran it and I've done that, but I don't really have a good comprehension of it, of the syntax of it either. So
yeah,
I was just curious because I'm like, well, if Zig is, you know, potentially, I mean, like I said, I've looked vaguely into this. Like, I view Zig as a real competitor if it ever gets off the ground to C, where I never really felt that way to Rust.
Yeah.
Does that make sense? So
no, I can see that. I could totally see that. And I think if I wasn't gonna do, like, if there was a language I had to choose beyond C or C++, it would have probably been Zig, or Jai if the compiler gets released, because that seems super duper interesting. The ideas that he's doing. I know Odin is doing some of the ideas that he proposed. but it's very different because Jai is actually being used. Like, he's developing the language in tandem with writing a game engine and a game in it, right? So like, it seems like it's gonna be very tailor made to tackle the problem spaces that I'm trying to tackle, right? That's a bold move. Yeah, it's super bold, dude. Honestly, geez, man. Like, there's the idea, that joke of like the 10x programmer, the 100x programmer. I'm like, that's whatever, right? But then you see this, you see him doing that. And I'm like, I'm willing to believe that's real now. Jonathan Blow. Let me see. But yeah, it's made me very far more conscious about this kind of stuff, and it kind of, yeah, this is his engine and game working in action. Let's get it. Where's the prettier version of it? You had a pretty one. Or just go on Twitter and find him.
You could always go with like the most weird language of it's called Dale.
Dale.
Let me send it to you.
Let me see the Dale syntax. But it's also terrifying. Yeah.
Yeah. Just pull that up for a second. That'll. If you can pull that off, I don't know anyone who could. And this is just like the weird niche of people who can't get rid of S expressions.
Dale
I just sent you a link.
Oh, you sent me a link? Okay, cool. Let me check it out.
In the general.
Is it like a
Discord?
Is it a ESOLang where it's like a language?
No, that's the weird part about this. It's supposed to be like a legitimate language.
Oh, okay.
It's just, and it's interesting, and awful, and not like it's. Yeah, you'll see.
No garbage collected programming language that uses S expressions for syntax, support syntactic macros. The basic language is similar to C with the following additional features: local type deduction, overload functions, anonymous functions, that's cool, reference parameters, initializers, destructors, variants, namespace. That's the biggest rub for me with C. I started writing my little toy engine in there, and I was like, you know what, we're going to get rid of, like, I could avoid complexity by just doing like a Unity build for this C program, and it's fine. And then, like, I quickly realized C doesn't have namespaces. So, like, all my functions have to I can already see the functions getting crazier and crazier in naming to support this. And I was like, all right, C++, but like, we'll use C++, but treat it like C, but still get the niceties. Concepts and compiler introspection modules. That's interesting. Dependencies, LLVM, of course you're gonna use that. I want to see what the syntax looks like.
Oh.
Is it
you've
Lisp?
already seen it.
Is it Lisp?
It's S expression, right? So it doesn't have the dynamic nature of Lisp.
You said I read S expression. I was like, I don't know what that is. We'll see what this is. This is okay. This is Lisp. Lisp syntax.
That's what I'm saying. Like, for people who love Lisp syntax, and like I said, once you get used to Lisp syntax, it's like something that you have a hard time going back because it is. I don't know how to explain it. It's just kind of nice.
Is it like Vim Motions, where it's like once you get over the hump of using it, you can't go back?
Right. It is like that. I mean, and you've seen that. I use Vim Motions too, right?
Oh, so it's beautiful, like, dude. I can't. I don't understand how people don't use Vim Motions. Like they're like, but I'm not gonna be able to write for like a month. I'm like, dude, it took me a week, and then you're good to go. Like, there's a week where I sound like a Neanderthal trying to type to people, or I sound like an 80-year-old trying to type. That sound like I have the words per minute of an 80-year-old and the errors of an 80-year-old talking to people on Teams and whatever. But then you get it over that, and then you're like, oh my goodness, I can navigate like crazy. It's amazing. Like,
yeah, totally.
I can't get over how just nothing compares. Like, nothing compares to the joys of just.
It feels like you're flying. Like it does. It's like, yeah, you're just like coasting, and it's great. I love it. So I would say this syntax is kind of similar, just because like indentation means something different in this, right? Because indentation actually doesn't matter, right?
Oh, it doesn't?
So it's just something. It's a convention, right?
Okay.
But the convention means something different, right? Because in every like algo-based syntax, and I'd even argue like ML-based syntax, like so C-based syntax and Haskell-based syntax, as people know them today. Indentation means like two things. First off, it means scope, right?
Oh.
And second, it means cyclomatic complexity in C, right?
Okay.
But in Lisp or S expression based syntax, it means just inherent complexity in general. Is the function inherently complex? And it's like hard to like.
That seems. I don't know what this means when you say inherently complex. Like, are you saying
Okay,
like
so-
the more indentations, the more scared you should be, or like?
So if go up to the one where it has a let structure in there. Yeah, right there.
Okay.
Sorry, I'm delayed on your Twitch stream, so
That right
it's
here.
the
Okay,
overloading.
I see you right
section.
here. Okay.
Right. So this main function, what it's doing here, and obviously I don't know this language, but I know S expressions and Lisp. So it's a main function, right? And it's saying it's a main function. It's an external function. It takes in an int and it returns a void, or maybe I think it's the other way around. No, it's a void function and takes in an int, right? That's what this is stating. But this let structure right here, what this is doing is it's defining three variables, A, B, and C, and then those are all points, right? And
This
then
hurts.
it's doing something with that those three points, right? And just by seeing the structure of the indentation, I know this is actually only doing one side effect. I know that because of the structure, right? I know it's only doing one side effect because there's only at the very end, there's only one thing in the same indentation area. And everything else before that is just definitions. And I know this is like something you can't explain to someone. You just have to do it enough. And then you're like, oh, so I can look at a structure. You can scramble all the characters in here. And I can kind of tell you, just based off the indentation in the parentheses, what the function, like, is it a side effecting function? Like, what type of complexity? Is there a lot of like conditionals in here where you can kind of do that in C based, right? You can tell if there's conditionals because you can, like, if you scrambled all the characters, right? You can kind of tell that, and you can tell scope, right?
Yeah.
Where scope is very different in here. Scope is like delineated kind of by parentheses, right? And so you know that like the print is within the let form because
I just noticed that. Yeah.
Right, because it's within the parentheses, but also let is a function of itself. I mean, it's probably not in this language, but like it can be, right? And so it kind of denotes a new scope with saying, hey, we're going to define a new scope, we're going to define certain functions, and we're going to do certain things with these things, right? And you can kind of see the same thing with the plus, like on just the function above the main function. They've defined a plus function for the points, right? That's what this function is doing.
For adding that structure.
And
Okay.
Takes two points and does return a point, right? And it defines a new point called R, and it's adding up all the x and the y's of each of the points, right? For A and
it's defining this new function based. Okay.
Right.
Yeah.
And then there's only really like one major thing it's doing is it's just returning the new point, right? And so it's building up a new structure. And you can know this just by the structure of the S expressions. And so if you even go down or up, I don't know, let's take a look at another one. Another form, I guess. Right here, this feels a little bit sorry.
I'm back now.
I mean, I don't know, just go fix somewhere. I don't care.
I got you.
Right, so this feels a little bit different, right? This is like this is just a side effecting function. I'm pretty sure. Maybe not. I don't know. The main function is just printing something, right? It's not doing anything, right? It could be returning something, but it's not like defining any intermediate variables. And so you just kind of just based off the structure. And actually, if you go down to something that has a lot more, I don't know if they'll have any like examples here, but like a really big, thick one, you can start to tell what's going on here, right? So you're defining a new sort of, I think this is a macro. Again, I don't know this language. I just know S expressions, right?
Mm-hmm.
But I can read it because it's S expressions, right? And so they have a let, and they're defining two things, right? And then they're doing two side effects, and then they're doing another let, right? And then this is kind of indicating, hey, maybe this function should be divided out into two different functions. Whenever you see two lets in a function,
Mm-hmm.
you're kind of doing something weird here. You're defining something, and then you're printing something, and then you're defining something else, right? You're having your IO or your impure function in the middle, like your impure process in the middle of a function. And if we're like being pure and dogmatic, then you wouldn't want to do that. And so just by the nature of I see printf in the middle of my Lisp code, I know that's a bad thing. I would divide this out into two different functions. I don't know what they would be, but like...
I hear what you're saying.
I would.
And
right.
you're saying it with a very convincing cadence. I feel befuddled and scared.
And
but also,
fine.
it's kind of alluring that you can see this and you're deriving this insight from it. Whereas to me, it just seems like noise. It just seems like the repeated parentheses just makes me think back to brainfuck. But if you know that language, but
no.
It makes me at least interested in like, okay, what actually lies on the other side of the hill if I let myself get Lisp brained.
Yeah, and again, like. It's just a different way of thinking, right?
Yeah.
Because again, when you look at C-based syntax and you look at the spacing and you look at the indentation, it indicates something else.
Mm-hmm.
When you look at something that's heavily indented in C, you say the cyclomatic complexity is really high for this function.
Mm.
But I don't know if that's necessarily the same truth for Lisp. It's just more of the function itself has a lot going on. And I know that sounds dumb, like, because you're like, well, if the function has a lot of lines, then there's a lot going on, right? But sort of, right? So like, for example, in Lisp, if I have a long function line, it doesn't mean I necessarily have a complex function, because if you go back to one of the let structures, like in the first let structure that we looked at, I could define, right there with the points, I could define A through Z amount of points and just print them all. Mm-hmm. And that's not, and the indentation will not be very deep. You see what I'm saying? Because it's going to be the same indentation the whole way down.
Yeah.
And that's not a very complex function. It doesn't do a lot, even though, because the indentation isn't deep.
Mm-hmm. Okay.
So, I don't know. Do you kind of see what I'm saying? Like,
I'm gonna have to marmalade on this a little bit. I'm not gonna lie to you.
Okay.
I'm gonna have to marmalade, but you're saying things. They sound convincing. That's the two metrics I'm working with here.
Yeah, and I think it's like fine, right? Like Lisp syntax is an acquired taste, I'd say.
Oh yeah, it's like the closest analog I think about it is like LINQ or even like reactive extensions, where it's like, okay, you have this whole idea of function chaining and piping and streams and doing all these different things to simplify a result. And it looks fundamentally different than how you'd normally program that without that. And at first, it's a very weird way to think about it, but as you read about it and as you apply it, you start saying, oh, it starts looking more normal, and then all of a sudden, your brain has its new built-in parser for that kind of thing, and you can make sense of it when you see it in the wild. And I imagine it's likely the same scenario here.
Right.
Geez,
yeah,
man.
that just brings me up one last point. I'm gonna pull up my stream or my screen again, if that's okay.
Sure, go for it.
one last little bit.
Yep.
Because you brought up like kind of link, you brought up like the streams and the extension methods or whatever. In Clojure, we kind of do it in a different way. Let me actually make some room here. Let me know if you can see my screen.
Yeah, I'm seeing it right now.
So what I'm going to do is I'm going to create a structure. I'm going to create a list of, let's call it fruits, right?
Mhm.
And in fruits, I'm going to have a name. This one's going to be apple, and the count or quantity will be 10. Let's go ahead and create like 3 of these. And let's name them something different. Banana, pear, and potato. And that's not a fruit, but that's what came to my mind. And let's do 80. Actually, let's do 2 more. Oh, 3 more. And I can't think of fruits right now.
Orange.
Kiwi, orange, and
Tomato.
tomato. Is that a fruit?
Yeah, technically it is.
Is it?
Feels
Okay.
wrong, but
I
technically.
trust you. I trust you.
I don't trust
so
me.
we can evaluate that, right?
Yep.
And so I could start defining functions on this fruit thing to do a whole bunch of different stuff. But I want to kind of show you like an operation of like chaining of how this is done in Lisp languages.
Mm-hmm.
Most Lisp languages have adopted this now. I don't know if Dale has because I've never actually seen Dale. But
How many people-
let me do.
1 second. How many
Go
people
ahead.
are even looking at Dale? Like, I'm actually wondering how much attention this has. That's guys, it's substantial. It's something. It's substantial. All right.
Yeah,
There's probably
I mean-
there's a good amount of Dale code out in the wild somewhere.
I would be surprised because like I don't know. Anyway, so let's go ahead and actually what we want to do is we actually want to pull out the quantity from all these fruits, right? So now all of a sudden we've just created a list of this. But let's say I want to increment all of these. Actually, I want to multiply it by 2. So I'm going to do that by taking the quantity and I will multiply that by 2 like so. Right, and you can start to see I'm getting into a problem here, right? And what I want to do is I want to add all these together now. And so I can do it like that by doing a reduction over it and doing the plus. I mean, I could do the same thing with multiplication, and that's giving me 0 because I have a 0 in here. But if I change this to a 1, then it would give me something like that. So a reduce, if you're familiar with aggregates and reductions and left fold, right fold stuff from functional programming, that's just what that is.
Okay.
So I could do that there, and that's fine. But this starts to become kind of a mess because I want to see a chain of operations, and I'm like, well, are you saying I have to go, like, I have to treat this like Haskell and I have to read this right to left? That's kind of crazy. Well, you don't have to, because it's macro based, because you can change the forms of your code very easily. They have one called built-in, which is a threading macro. And so I can rewrite this to be like, hey, I want to take this fruits thing and I want to map it or to thread it into this. And then I want to map it to do this by timing it by 2. Right?
Okay.
And then I want to do a reduction on that.
And this already looks
and then-
far more familiar.
Right, and then let's say I want to add another 100 to that. I can do that because remember, it's not an operator, it's a function now, right? And then let's say I want to apply that to a string and say, my fruit count is now that, right?
Okay.
And so that's just like a simple way of you can just look at this and go one thing to the next to the next. And so it's kind of a dot operation type of thing, right? And so this is how they do it. This is why they don't actually have like dot operators, because now you can start to chain this to any function, right?
Yeah.
You don't have to do an extension method. I can literally make an anonymous function right here and say, pass in my string, and I want to say, I don't know, my string will now be appended to another string, which is hello world, right? And then I append that to my string, and then I apply that, and so you can say, hello world, my fruit count is now 550. Where this is in C#, if I was using LINQ, I'd have to go and make an extension method to be able to be applied to for like a dot operation.
Yeah. Or do something
But
other jank, but yeah.
Yeah, or do something else. And I mean, it's not really a big deal. It's not like, oh my gosh, this is why you should use lists. That's not why you should use lists. And it's
Yeah.
not even really a big problem in C# anyway. But this is just one of those interesting things like, oh, because of macros, what this is doing is this is literally rewriting the code. I'm going to expand this macro for a second. And so you can see what this threading macro does to this code. Let me do that. There we go. So you can see down here, this is actually what the code is being expanded to, and I can copy that and maybe paste it.
Yeah.
Maybe not. I don't know.
But it's like similar to what you're doing, just with the right to left operation.
Uh-huh. And so it's just literally modifying the structure of the code to be like this, and literally thread this into the end of each form there.
That's nutty.
Right.
That is super nutty.
And so it eventually expands to that, right? And so it starts with mapping the quantity of fruits, and then it times it by 2, and then it reduces it, and then it adds 100 to it, and then forms that into a string, and then pass it into my anonymous function right there, which also appends it to another string. So it is kind of nutty, right? And this type of stuff happens, because of this is why the syntax of S expressions is the way it is because it is a list. It is something that you can manipulate, and so you can do weird stuff like this. And if you want to say, hey, I want to make a new if form. Right?
Yeah.
I hate how when it's the true case always comes first, and I want to invert it, right? I don't know why you do that, but you can, right? And that's like macros 101 that you can do in a few minutes or whatever. If you wanted to make your own control flow, right? And so people start to do some crazy stuff with this. And so with Dale looking at it, I think they said they have macros, right?
Yeah, they
Or
have
maybe
macros,
don't.
and they showed an example of it too. Here we go. Yeah, but it was one of the advertised. Was it not? Compiler introspection, namespace invariance. I thought they had a macro example. Macros here, yeah.
Gotcha. Yeah. So yeah, they take in, the Lisp or the list essentially type of stuff, and then they can do stuff with it. This is a little bit different type of macro things I've ever seen in other Lisp languages, so I'm not exactly sure. Well, I can tell you UQ is called unquote, right?
Okay.
And I'm guessing UQ is quasi-quote, which is again just more of like Lisp type of stuff, like
okay.
I've shown you, this is a quote, right? 1, 2, 3, 4. Like if you look at my stream or my
Let me switch your screen.
That's a quote.
Oh,
right?
that's a tick that indicates it's a list.
Yep, that's a quote.
So
you can even do it like this, I believe. Yeah.
Got
If I want to
you.
unquote, I can do that, and it will throw an error because it's like. But if I did that, it would actually still throw an error because apparently I can't do it that way. I think I would have to be in the def macro form in order to unquote like that. But anyways,
All right, that's a lot, dude. That's I have questions, but I'm scared of going down a rabbit hole.
yeah, it's definitely a rabbit hole.
There's a lot to process here already.
Right, and what I'm trying to get across is, again, I'm not trying to be like, hey, you should use S expressions, but what I am saying for me is like, I've already been sold on S expressions, and that's a problem. I have a problem now.
Yeah, you can't go back.
And it's hard for me to be like, well, I want to do some lower level like stuff, but I just love like the simplicity and the S expressions are beautiful. I mean, this is C. Like if you're looking at Dell, this is like C, essentially. Right.
Yeah.
But it is, in my opinion, some of the most beautiful C I've ever seen. Maybe to you this looks horrific. I actually don't know. But to me, I'm like, oh my goodness, like
Well, and
This
it's
is extremely elegant.
yeah, it's like the knowledge, right? Like people, they see my Vim stuff, right, and they're like, "That's terrifying. That's terrible," right? But once you done it, you already got it, and it feels you can't go back. It's amazing, right? It's like the same thing here. I imagine
Yeah.
the same thing here, but that also makes me kind of scared or trepidatious about even learning it because I'm content with my my structuring, man.
Totally. And if there's only one thing that you can take away from it is just to be like, if someone likes this stuff, you can be like, yeah, I get why you like it. Instead of the immediate kind of knee-jerk reaction I see a lot where it's like, you Lisp, right? You know,
Yeah.
at the very least, just be like, okay, it might not be my cup of tea, but like,
Yeah. Oh,
I
I mean,
understand why someone could like something like that.
yeah, I've been going through this weird thing where I've gone from like initially just like functional program is dumb to like, all right, there's some functional concepts that are actually actionable and usable. And now I'm like, okay, there's still reasons I wouldn't use it, but I can understand why people are using it to model things, especially like an application level. Like there's actually quite a few benefits that come from it. So I can't knock it as readily, right? Learn about
Right.
this. John said, "Thank you for explaining all this. It's cool to learn about because it's different from the tools I use." Yeah, this is super foreign. Like I didn't even know there's like this. Like I know there's like a conceptual difference between functional and non-functional programming, but then there's this other level too, syntactic wise, of this S syntax that I never really knew about. That is
Yeah.
interesting, yet there's like this aura of oppressing aura that comes from it too.
Yeah, for sure.
What language
I
you
think-
started with? Like, did you said you started
started professionally or
no, wait, with functional language, or I guess with S syntax specifically.
S syntax was Clojure, but
Clojure.
functional I did F sharp, which
Okay.
which F sharp is a completely different syntax, right? It's more of the ML syntax, right? Or Haskell syntax.
Yeah.
So, and both, like all the different syntaxes have their strengths and weaknesses, right? Like, I'm going to be honest, S expression or Lisp syntax, it doesn't scale as well in terms of like a single function. And this is, as weird as this is going to sound, a pro and a con. Because if the syntax doesn't scale as well, you're actually more likely to start breaking apart your function sooner. Because you're like, this is getting unreadable.
Yeah.
And so you kind of end up with smaller functions, cleaner functions, because the syntax is inherently, in my opinion, not as scalable. But with like C-based syntax, it scales pretty well. Like you can actually have a really big function and kind of follow it from the beginning to the end, almost like a story, right?
Yeah.
It's doing this, and then doing this, and then doing this, and then doing this, right? And then somewhere kind of in between and completely different, like Haskell, right?
Yeah.
Yeah, it's very different, right? It's optimized for very different things.
Like we mentioned, like even with that discussion between Uncle Bob and Casey Moritori, like there's languages that are made for different problem domains, right, in different levels. And like even like we talked about, like there's certain problem domains where it's like it requires that performance, so you have to do that. And then there's other places where you actually want to think things less so in terms of data and more so in terms of concepts or ideas and manage state in that kind of way, right? So it's kind of interesting. Like I think I don't know about you, but at least for me early on, it's very easy to be like, nah, my thing is sick, right? But the more I
Right.
learn, I'm like, most languages have some merit to them. You know, like this person sat down to make this likely because they encountered some specific problem and the current tools didn't work well with it. Or like Torvald said, like it's not, if you have to make a project if you have to make a project, it means the world failed to provide a solution for a problem you're having, right? So,
Right.
you know, if you want to be very optimistic, these languages are at least with the intent of solving a problem.
Right. And the language that I'm like most excited for that's probably not going anywhere right now is called Carp. So if you just Google that real quick,
Carp.
I think you'll find it interesting because you have experience and Carp language. Yeah.
Yeah. I was like, I forgot there's animals. That happens all the time with
Right.
programming languages. You type the
Yeah.
language, and it's usually named after an animal or something very generic.
Right. Like in
Yeah.
F# we have a framework called Giraffe, and I like searching giraffe like headers, and it's like I get like giraffes. And I'm like, no, that's not what I need. So this one's interesting because
REPL?
it's trying to get the best of both worlds, and it's of all worlds, and I don't know if it's going to succeed. Where it's using S expression syntax, but it's using Rust borrow checker and ownership mode.
Oh, that sounds like the worst of all worlds.
or the worst of all worlds. I don't know.
No, that's okay. That's interesting though. That's interesting.
Right.
So they're
And
buying into
it-
Rust solution being like a being right.
Yeah, I think they like the idea of no garbage collection.
Hey, SDL. That's cool.
Yeah. And so like this is low level stuff that I don't really get. I don't understand it, but they're doing like the strong type system, the static types of. But again, because they're using the Hindley-Milner syntax or type system, that it's inferred types like Rust. Because like Rust infers a lot of types, from what I understand, right? Maybe, I don't know, maybe not.
Yeah. Yeah, they know that
so-
Rust does do type inferencing.
Yeah, and so maybe the best of both worlds, maybe the worst of both worlds, but
Well, it
The
depends.
thing
If,
is-
like, yeah. Oh, continue.
this syntax does give you macros easy, right?
Mhm.
And from what I understand, macros in Rust are kind of hard.
Yeah, I don't like.
Um,
I purposely avoid macros in Rust. It does not. It's not very nice or intuitive. That's the strangest
Yeah,
SDL
so-
code I've ever seen. Yeah, I saw the SDL. I was like, that looks funky.
So go to the examples of Carp, I think.
Yeah, examples here. Where's the
Yeah.
Carp demo? Carp game of life. Carp.
Yeah.
I want to see one that has
Yeah,
like.
this is, well, I'm just kind of really like, this is interesting for me to kind of show you because you've done a lot of Rust.
That's
you've
funny.
done a lot of lower level
There's no.
stuff.
There's no. There's
Right.
no syntax highlighting for this yet.
No, there is.
Yeah, you just raw dog it the way it's supposed to be. Back in my day, we used Vi. With no colored syntax, none of that. All right, load SDL core SDL.carp, SDL image, SDL app event key code mouse. Okay, where's gonna be okay? And then they have a function for handling key presses let. And then they're doing. Is this matching?
Yeah, that's yep.
Condition. Yeah, matching. That's how they do matching. Oh, that's wild.
Yeah, I think that one might be not a strict pattern match. I think that's a conditional, but I think they do have pattern matching in Carp though.
Yeah, key space, not play, and then unrecognized key. Interesting. And then mouse handling.
Yeah,
okay.
that and I believe is like, I think that has to do with ownership. I don't know what that would mean, but I'm pretty sure if I remember, it's been a while since I've looked at that. This has to do with ownership here. So
Okay, so there's something that's allocated. This is getting a handle to that thing instead of. I guess that's like how they deal with pointing. Or I guess it's like a Rust equivalent of references.
okay,
And then then they have this mouse state dot get. So okay, so no, they actually do have. Interesting. Okay, index plus, and then doing some
that is
math
equal
here.
to mouse, and then index is equal to this math equation, right? And then at the line 32, this is where they're bringing it all together, where they're setting the world index to be not whatever this unsafe nth world index is. I don't. Again, I'm not entirely sure.
Show the
right?
end body one. Okay, let's look through the end body one that he requested. If I can find it.
I said land
It's
is no
second from the
core.
top.
I think he's referencing near the top. Okay, benchmarks, bugs, carp demo, carp, derive, drop, external, fonts. Oh, wait, this should be,
The
okay.
benchmark and body, I think. So with a B.
Oh, there we go. Benchmark and body, okay. Okay. I'm not sure what end body
I like
is.
how they have like
Wait, is this comments?
regular.
Wait, their comments are with semicolons?
Yeah, that's kind of typical. It's weird.
Is that really a
But-
normal thing, like in other languages?
In other Lisps, yeah, it
In
is.
Lisps?
I don't know why they chose to do that.
Brother, what?
You have to understand, the Lisp syntax is old, okay? Like,
Okay.
it is old. Like, Lisp syntax has been around since the 60s.
I'm not
right?
gonna hold it
So-
against it. There's like a functional. I need to find it. There's like a functional Lambda book that uses a list for it. That's like from that. It's the same exact book from the 70s I was used back then at like MIT or whatever. I was like, all right. I'm not dogging it. I'm just. It's a culture
Yeah.
shock for me.
It is strange, I will admit. So,
No, they have iteration. They have like, wait, what? No, this is commenting. It's commenting the logic. For a second, I thought I had normal like iteration blocks
Yeah.
here.
coding regulars.
Yeah, I was
It's
like,
like C
oh, is it like
code.
OCaml? You get to have the best of both worlds, normal iterators, but like still be functional. Bit and Y. Okay, so this is a plus divide equal. Oh, that's in. Okay, so you're defining this is a function that because we talked about normal operators, right? Like the plus and whatever. But there's also ones that operate and assign. Is that a thing?
I don't know. I don't know what that is. I'm gonna be honest.
Okay.
Maybe I think you're right. I think that is divide equal, right? So it like takes it and then divides it and then sets it to itself or something. I don't know.
Wait, that's Y and 0. No, that'd be weird then, because
Or
it's
is
like
that
it's.
just not equal. Maybe.
Yeah,
that's
that
what
might be
they did.
what it is actually. Yeah, not equal.
Okay.
That makes more
Yeah,
sense in this
okay.
context. I was like,
Yeah,
wait,
that's an interesting choice, but whatever.
okay, that's fine. We could parse at least, and then do, and then set.
Right. So,
So,
if you think
okay,
about it,
so
we
it's-
don't. There's not an equal. An equal is a comparison, right?
Yeah.
So setting something is very explicit and very deliberate that they try and make sure these are different. Where that's actually one of my criticisms of C-based syntax is we use the equal for setting, but double equal for comparison.
Yeah.
And it's kind of weird when you think of it that way because like equal isn't really setting something in mathematics. We're actually making a declaration of something.
Yeah.
Programming it to
That's why there's like the Walrus operator, right? Because that goes back to the discrete mathematics and the way they, because like in discrete they like have to differentiate between comparison or defining versus assignment. They have like the Walrus operator there for defining that.
right.
Yeah, which I get. It makes logical sense when it comes to that from that perspective. I'm just so ingratiated with C. But I think if
Right.
if you had to make a distinction between the operation of comparison and assignment, then that'd probably be the way you do it.
Mm-hmm.
Okay. Bit and. So there's a okay.
Yeah, so just a bit and operator, I guess, with the Y
Yeah.
and one. So
That's I'm assuming as well. Okay. X squared. Okay. And then,
and then
you
they're
define-
returning R right at the very end. Whatever's at the end is what they return, right? It's
Okay.
always they always because they're trying to be referentially transparent, so they're always trying to return something ideally.
Gotcha.
It's kind of the practice in all of functional programming, not just Lisps. So
Okay.
So that's where Rust kind of picked it up on, except for Rust has implemented it in a weird way, because like sometimes you have to explicit return and sometimes you don't.
Yeah, it's odd. I mean, it's not. It's weird. It's something you forget about. Like I do it, and then I forget that that's something you can do. You have the option of both. You can do explicit returns, or you can just do. Interpreted. I don't know there's another word to better describe that, but assumed. I guess I don't know.
Implicit return.
Implicit return. Yeah, that's the word. Yeah, implicit. Okay, define solar mass.
And they have like types, right? On line 37. That's kind of, weird because we don't see types like that in normal Lisp.
Yeah.
Right? Or Clojure specifically in Lisp maybe, but like, and so they're actually defining a type or a struct basically where X double, Y double, and it's going to feel weird because remember, spacing, it's not spacing, but like indentation is optional. Right, you could literally put all of your Lisp code on one line and it would still work technically, like your whole program.
Yeah, minify it.
Right, and so this is them saying, "Hey, I can." They could literally expand this out and say X double return, Y double return, Z double return. They could, but
they're trying to be nice to us.
Right.
So a planet's defined by its X, Y, and Z, and then what is this? Velocity X, velocity Y, velocity Z. I'm imagining, and then this mass. Okay, so it's like a gravitational thing. So it's like a n number of bodies that you're operating with, 3 component position and velocity. Got you. Okay, yeah, that makes sense. And then you're doing force calculation with that. Then okay, or not force, but I guess in this case. Gravitational force calculation. Got you. Current. It's unmuted. And then they're defining something else here. But here we defined a type. This is just a function. Okay, never mind.
Right.
I think. Okay. Yeah. Continue.
A lot of these things are like these types. They would be. They're inferred, right? And so B on that function 50, like on line 50, that's a function. B is inferred as a planet.
Yeah.
And so that's why you can get the.
I wonder what
the mass.
This ampersand. That's not an ampersand. That's just an at.
Yeah. I think that's copy or that's deref or something. I don't know.
Okay. That's not a Lisp like syntax thing. This is a Carp
this is an
thing.
ownership thing, right?
Okay.
I remember reading something about that. I don't exactly remember what it is, what the at is and what the and is, but that's supposed to make that's the ownership model. Because it's kind of easy to forget in this that there is like the Rust ownership model going on where they're passing things by not actually, I don't even know how it works, but like they're just passing it. I mean, you can explain it, but
yeah. Right? I'm trying to understand this because right now they have what I assume is a pointer and then something that's modifying or indicating read-writability. Like, I mean, Rust is super simple though. It's like if you have like a function f do thing. In fact. I have Writer or Rust Rover open, or did I close it? It doesn't matter. Do thing, and then you have an input of some kind of structure, I don't know, object, and then you're defining a reference to that struct. I don't know, entity, whatever. It's super easy. If it's just this, that's read only. If you need to mutate it, you just add mute to it. So I'm wondering if that's the same thing here, where instead of that, this is an ampersand, I think. Instead of just an ampersand and then the addition of mute to indicate mutability, if it's like, no, this is defining that this is a reference, and then this is defining either immutability, I don't know. That might be my guess. It'll be weird if they're making you explicitly define that it's a immutable reference.
Yeah, I'm gonna pull it up,
okay.
And the doc can see.
Define offset moment bodies. Let
ownership.
be. Unsafe nth bodies. Wait, are they doing some unsafe stuff? Is this not idiomatic carp? Within the carp examples? How dare they?
Okay, so the to temporarily lend a value to another function, a reference must be created using the ref special form or the and. So when we see the and, that's a reference essentially.
Oh, so it's like Rust then. Not the at.
I don't know what the at is for yet.
Yeah, that's so it's not, this is not defining a reference then. But it says it's doing some unsafe stuff, so maybe just straight up a pointer. And then this is the address.
Okay.
Maybe that's what it is. I mean, that makes more sense in this context to use an at.
It's copy.
Oh, it's copy?
Yeah.
Okay, so just copying a copy of the reference?
Yeah.
Okay.
Because
Interesting.
otherwise it'll consume it, right? I don't know.
Oh, yeah,
Maybe.
yeah. You're right. It will consume it at once it leaves scope.
Right, and this is, yeah, I think so.
You know, honestly, this sounds weird. I don't dislike it. Because, like, it's terse, but once you know it, it's fine. The thing is, the one thing I hate, okay, there's a lot of things, but one thing I dislike about Rust strongly is how verbose it gets. And it's verbose without any meaningful information because all you're just doing is calling a lot of clones or copies. So it just muddles things up and makes it it gets away from the actual logic you're trying to do there, right? Because there's all this tax you're paying for this borrow checker. This is saying like you're still gonna pay that tax, but it's just gonna be 2 characters as opposed to like 5 or more characters.
Right.
Okay, interesting. I'm not strongly opposed actually. Okay. And then energy. So there's a function energy that takes in bodies, I'm assuming? Or it's operating on bodies.
Yeah.
Okay.
It takes in bodies, right?
Okay.
I have no idea what a let do is and how that's different than let and then do.
Maybe it's concatenating both. I don't know. And then there's 4.
Yeah.
Okay.
It's simple. That's simple.
Yeah.
It starts at 0, goes to length bodies, right?
Gotcha. Yeah. And then another let
then
do
that's
unsafe
B.
nth bodies I.
And it sets that to B, right? So.
Gotcha. Set
I don't
E.
understand this algorithm at all, but yeah, this is the worst part of Lisp is the mathematics. You get used to it, but it is the worst part of it.
I love that call. You get used to it. It's okay. It's not great. I can't even defend it. It's just, that's the price you pay
Right.
for beauty. Okay. Be the die bar. What kills me every time is just seeing all the parentheses stack up at the very end.
Right.
That's amusing.
That's one, again, that you get used to as well. And it is the price you pay, as you said, because what you actually get back is you get more functions on your screen.
Yeah, doing 3D graphics related math, this looks like a pain, but that might just be the fact that I'm not used to reading this. Yeah. I'm thinking a little column A and a little bit of column B. What's up?
Let me send you one more thing. I've just given you the whole gambit of Lisps, okay?
Hey, man.
Um,
I opened the door when you knocked, man. Want to hear what you got to say, man. Magic
this
Lisp,
one's
man.
called... Right. This one is called...
Oh, they defined the line. It's here.
Actually...
Oh, here's the actual main function. Cool. And then you can see everything just run. Just do its thing. Wait. Why is it defining an empty body here?
in this collection. Huh, not going to implement this, man. Not in carp though, but
Sure.
all right. What
Yeah.
do you got for me? What do you got for me?
Um,
Oh, I did have
unfortunately,
writing.
this thing is not behaving. So I'll have to send you the less impressive one, unfortunately.
Oh, it's very sad.
Let's see if Twitch is gonna, if I send the link, if they're gonna automod me.
I got it.
No, no. So that's for John too. If he wants to click on that.
Okay, what do we got here?
So this is a Lisp called Janet, and Janet is basically a Lisp that is ran on a C runtime or whatever.
Okay,
And so this is why it can be compiled down to WebAssembly and thrown on the web.
gotcha.
And this specifically has created this person has created their own custom DSL for sort of graphics, 2D graphics here, Turtle graphics.
Okay.
And so you can kind of click on the examples and on the left-hand side and start playing with that. Unfortunately, the cooler one is this one, but I think it's broken right now, and maybe it's just broken on mine. Maybe I have some sort of cache.
Yeah, that reminds me of there's like this, I don't know, there's like a website for learning shaders that compile shaders real time. Oh, shaders usually like that, but yeah, you can like edit the shader code here and then it'll update in real time here. Is this actually shader code? Is this like a shader
Yeah.
language? Oh,
Sort of. Again, it's a DSL, right? And so you can like comment some of this out and uncomment it, right? Because again, if you go through the whole editor on the left, he's kind of giving you a little tutorial, right?
Mm-hmm.
And so if you actually go down to the next line of code to like 39 and then uncomment that,
Okay. Oh, cool. I have that actually 3D printed here. I got that from work. This is. I have a curse question that I'm gonna have to find out. LSS syntax, shader language.
do S expression.
I feel like someone has to have done this at some point.
You might want to type S expression instead of S syntax.
Oh
That
yeah,
might
yeah.
have-
S expression. Slang.
And again, this doesn't exactly make sense to a Lisper when you say S expression syntax language, because what they would do is they would take their existing Lisp that they prefer and they would rewrite a DSL into that Lisp. Does that make sense? So like this Bobble Studio or whatever,
Yeah.
this
Wait,
is someone creating a DSL in Janet to be somewhat of a shader type of syntax.
Yeah.
And I think, let me actually, the guy blogs a lot.
Yeah, because I feel like, if not that, like I feel like there's gotta be some. It must be possible to like I wouldn't be surprised if someone made a transpiler to like HLSL or something like that. Like I feel there's gotta be some overlap between like S expression or Lisp enjoyers and graphics programmers. There's got to be
Yeah.
some overlap. So someone at some point must have done something like this to have S expressions within
Right.
slang compiler.
Um,
No, that's something else. That's something different.
if you
Yeah,
go to
it's a
that blog,
Okay.
actually, and then kind of scroll through that, that's the same guy who's made these cool little toy things that I've shown you.
Yeah.
He does actually talk about shaders, I think, for a second. I don't get it exactly what he's doing, but he's kind of creating his own DSL for shaders or whatever here. But
Interesting.
I don't know. Like, I don't ultimately know, because from what I understand, aren't like shaders like in some sort of like C base dialect most of the time because they have to be incredibly fast?
No, so you write within something called, well, at least for us, like in Unity, we use something called HLSL, and then that gets like compiled to, it's like a high level shader language, and then it gets compiled down to what's actually used at the end of the day. So there's like a distance between that.
Gotcha.
Yeah, and there's other shader languages like that, but I honestly don't see why this syntax is like fundamentally untranslatable to there. As the only thing is that if mathematical expressions in this are a pain, then it's gonna be kind of a pain in a shader language, because a lot of times you're largely just doing mathematical expressions in there. In fact, that's kind of the big thing you're doing in shaders. So maybe there's a reason.
Go ahead and look at some of these examples though. Like look at the code here. You'll notice some of the mathematical expressions look normal. Because remember, this is Lisp, and when it's Lisp, you can change the language however you want.
Mm-hmm.
And so if you look at that, it was one of the examples. I think it was the third one, maybe fourth one. There's just a regular infix operation of mathematics.
Oh, he does?
See that?
He has one compiling to a fragment shader? All right, here we go. Def redirect, please website, cooperate. Of sorts. Okay. Interesting.
So math, again, so he can just immediately, because he's modified the language, and you can just do this as a simple macro. You can write your own infix operators and modify the entire S expression to do math in a normal way, like he's doing right here.
Yeah.
And
this seems
like
far more readable.
Divided by 30 or negative 30, right? Because he recognizes math is hard in the normal S expression way, so let's just rewrite that to be in a better way.
Yeah. So it seems he's covered, like he's made some custom commands specifically or functions for that kind of stuff.
Right.
For like the common things.
Yeah. So again, this is kind of what I was talking about, how like the curse of Lisp, right? This person has modified Janet to the point where this would be not actual proper compilable Janet code unless you have his macros in that. So
interesting.
So it's a pro and it's a con. It's cool and it's also a pain.
Hey, this is cool though. Doesn't hurt to have something like this in the ecosystem.
Yeah.
Yeah. Yeah, and it says right here eval 39 milliseconds GLSL, which is like another high-level shader language.
Okay.
Yeah, it's not like they're not too different. Oh, what is that music that just started playing? Oh, I forgot my SCP research ambient music. I found it so funny that this whole conversation about Lisp had this as the backdrop of it. Like, and it kind of matches it, because this whole Lisp and what you're bringing here feels like a language that was in containment
right.
for reasons that is broken.
It's kind of
out.
an alien-based type of language or whatever.
It's foreign, strange. I'm not sure if it's here to hurt me or to save me.
Right.
It's good that there was some background thing playing. Yeah, John. I don't want to mess with you. Yeah, there was ambience. There was some ambience in the background. This is cool though. Yeah, I've been doing some more graphic stuff. So this is. I think if I were to learn, like, in reality, right? If there's a place where I'd be likely want to experiment and play around with this, it would probably be in something like this. Yeah, this guy's awesome though. This is super sick stuff that he's doing. I'm gonna save this. I'm gonna bookmark it. Put it in my programming bookmark. Dude, you are a wellspring of knowledge, man, for this.
Just like
He's got these
weirdly
references.
obsessed with Lisp in the last 2 years.
Hey, man, that's what happens. Everyone has their thing that they hold on to, or they just get attached onto.
Sure. Yeah, for sure.
Yeah, Rust is my personality trait, but now we're about to lose that. Now I have to find something else to make my personality quirk.
For sure. I do got to get going. But
good, man.
it's been great talking with you. I've learned a lot, so I appreciate it.
Yeah,
And,
man. Likewise.
Yeah, I'll talk to you later. I'll make sure to follow, and if you ever stream again, I'll see if I can catch a stream. So
Oh yeah, regularly, man. Regularly. I'll be catching you though, all right? And yeah, feel free to pop on like a call or anything like that too, man. It's super interesting talking to you. There's not very much times I get to talk with programmers not related to work.
right.
So it's very
That's
cool
true.
to have an opportunity to just get into this kind of stuff, man.
Yeah, for sure. All right. Well, thank you. I will talk to you later.
All right,
have
catch
a
ya.
good night.
Peace.
See ya.
Take care. Well, now I feel empty, man. Where do we go from here? We had such a wellspring of knowledge. Why would I want to go back to programming in C#? Look at this. I can understand this. That's wrong. Not nearly enough parentheses. No, that was super cool though. I learned a lot from today, guys. And hopefully, I mean, it seems like you learned some stuff from this too, right, John? This went like the needle has been pushed for me, where it went from like this Lisp stuff was like in my mind in the same category of ESOLings or esoteric, yeah, ESOLings. Either that or ivory tower type languages, where it's all theoretical, not much application, and it took me over a little bit. I'm not gonna lie, this is super cool. Super duper cool stuff, man. And now we're back here in this land of Unity, which I want to escape. And I feel like every single day I get closer and closer to just... I feel like I keep rewriting custom components for Unity. At some point, it's just going to turn into its own engine that just so happens to be started by Unity's main function. Like, I'm not sure if you're seeing this, but like, what should we call it? Let me load this. Where's my lighting stuff? Load. Is this the correct level? Yeah, like we had to write our own, like we had to extend Unity's terrain stuff to have proper tiles instead of just 3 different things, and then we did our own lighting thing so we can have vertex. I mean, I did it for fun, and then I also wanted to try to see if I can get like the vertex lighting, or per vertex lighting versus per pixel stuff. But now we're having issues. We're having problems. What's going on here? Drop profiler frame data to reduce. Oh my god, I've been profiling this entire time. Very sad. I'm in a weird crossroad though. I'm not sure if I want to, like I said, I'm probably going to drop this. This was cool. This Rust stuff was cool. Very interesting. Learned a lot. Like it. I think I want to get off the bus a little bit. Like I mentioned earlier, I want to get off the bus. Oh my goodness, dude. What's going on here? Stop. But yeah, man. Let me get this. Let me close this. What is this? This is DLL stuff. Yeah, that's something else. I'm about to start a game project in the custom engine. Unity just hurts too much at this point. Yeah, I feel that. Custom engine as in like one you're making yourself, or custom as in like a not Unity, Unreal, Godot, off the shelf stuff. I really wanted to like Godot. I really did. I sincerely tried my hardest to like Godot, and it just did not work. Did not work out. Come on. Do I have to recalculate? What's going on here? You were working just a second ago, man. What happened, dude? Oh, wait. There we go. Now we have proper lighting. Proper lighting. But it was not for me. Yep, same here. Just started from empty C++ project, writing the game. Yep. Honestly, dude, I love just starting with a fresh project. There's something so good about it. Of just being like, hey, we're gonna be The world is my oyster. What is that saying? Give me Vim and give me GCC and I can code you the world. It's like that whole idea of Mythical Man Month, where like the more people who get added to a project, the more diminishing returns you have per programmer. Like you start having that same kind of cost when it comes to complexity in terms of the more code you have, the more. And this is not, the shadows aren't rendering properly. Why aren't the shadows rendering properly? I specifically requested having good shadows. Where are my cast shadows? I specifically requested them. Did I do something stupid? Oh, maybe I did something stupid in a shader while we were talking, and that's why things are not working as intended. If I did, I don't know where. Cozy Light, Smart Tyler. Nope. You belong there. I don't know. Kind of worked that way, I feel like, in a sense. Yeah, it's kind of an inevitability. Like if you're working on a project of significant complexity, that's just going to happen at a certain point. Which is why I find myself starting a bunch of games but never quite finishing them. Though this game's been a bit different because there's a lot more I think I've talked about this quite a lot. I spend so much of my life dealing with the bare bones of making games, or I guess like the lower level mechanics of making games, like art, programming, music, that kind of stuff, right? So I spend so much of my time just worrying about the low level things regarding making a game. But now that I'm at this point where I feel comfortable and confident in my abilities, I'm faced with this reality that I have not had the same amount of practice in designing a game, which is very different. It's a privilege to get to that point of now being able to think in terms of design and what is this game going to be? And in the case for me, right, I not only just don't want to do a game that's just mechanics, or I guess not saying that just mechanics. I don't want to make a game that is, how should I say this? I want to make a game that expresses an idea through its mechanics, right? That's a better way of saying it. Well, the games I do have done before have been a lot of times just taking pre-existing mechanical ideas, maybe doing some permutation differences on it by combining different stuff. So it's unique in terms of like combinatorics, but beyond that, there's nothing quite either personal or doesn't say anything. So now I'm in this position where I'm like kind of thinking about those two components. And my last game, I kind of stopped working on it because I realized I've crossed the hurdle of the low level stuff, implementation, all that kind of thing. But as far as design directions for what are we designing the mechanics to be and what is this game going to be about, there was a lot of ambiguity that arose from there. And without really clear direction, you know, I could keep pushing forward. I just wouldn't be fulfilled with the product we're making, or the thing we're making. And games are a hard endeavor, right? They're quite the investment, and they're quite inherently risky. And I'm not trying to make the game for as a product first, but it is a thing to consider. And yeah, so that led me to this point. That's very different, and I'm hoping I finish this game. But at the very least, the game has something very distinctly different compared to the other stuff. That it seems to have a bit more of a focus to it, and a bit more of a But yeah, that's like something I've been wrestling with. And I actually had to take some time away from work on this to be like, all right, we don't know much about game design in actuality. What does this look like? What What do people have to say about designing games? Or even beyond that, I'm making a game and I don't play games very often. So I'm not even exposed to the environment or the zeitgeist. So let's play some games, let's read some books, and consume some media so we can understand what's the landscape of games, what are things that currently exist, what are some media that are widely considered artistic, and what kind of value do I get from them? Not what other people get, but what value do I find in it, right? And then go from there. At a point in game dev before, that wall where you actually have to make a game. Yeah, that's exactly it. It's exactly it. All of a sudden you have to make decisions about what's your EGL, right? Like, what does their EGL even look like? What's the driver behind this? I am kind of befuddled. This is working perfectly fine. And all of a sudden, this is no longer working. And in fact, the shadow maps is generating, or not the shadow map, the depth maps that are being generated are just wrong. Why is that? Cozy light settings. Did I do something while we're talking? Did I do something dumb? I feel like I might have done something dumb and not realized it. Have to get going, but we should chat. Oh yeah, 100%. Dude, anytime, John, you want a Discord or call or whatever, hit me up, dude. I'm free. Usually in the evenings, but I'm always down, man. And yeah, we need to organize a get together again too, man. Another one. I've been meaning to do it. We were supposed to do the game jam, but I didn't. Game jams while working on this project are kind of less alluring. I think I want to do them after I finish this up. But yeah, man, anytime, dude. I appreciate you coming by though, man. That was a super welcome surprise. And I hope you're doing good, man. And in fact, actually, that's a good time because I think I should probably end the stream here, so, and get to bed because I have to actually get up in the morning. But yeah, thank you for hanging out. Appreciate the company and hope you guys enjoy. Have a good one.